NOAA, NOS, Papahanaumokuakea Marine National Monument. Keone Kuaha is going to lead an Oli, and I will turn the mic over to him.
And is there a PowerPoint coming up? Oh, wow, nice. You see, I didn't make that. So I'm just going to take a few minutes this morning to discuss the opening chant that we're gonna, some of my colleagues and myself will be helping with this morning. And the reason being that it's always good to understand, sort of have a singular purpose, and usually when we open with chant, it is to create some sort of singular purpose. I was asked to do this by Don, just to recognize sort of our place, as well as to bring in this other layer, cultural layer into our work, especially those of us working in Hawaii, but really almost anywhere in the world you work. There are layers of cultural knowledge that are in that place that we're working in, and that can impact our work in various ways. The chant this morning is Pukamai Kalai Kumukahi. I'm just going to have us say the words just to kind of hear them come out of your mouth. Everyone together, Pukamai Kala. And just to foreshadow, I'm not going to make you chant this, so no worries there. Ikumukahi. Pukamai Kalai Kumukahi, and you can see the translation right there. Really appropriate for as well. It feels like today's event is sort of emerging as well, right? You folks have done some good work this summer, and you're here to show us that. And so the word puka also means to graduate. Not that there's a graduation, but it has that sense of emerging forth into a new level. And then the word kumukahi, and this has to do with our meeting today. Kumukahi can be interpreted, it's a place on the eastern point of Hawaii, but it can be interpreted to mean of singular purpose. And so this is why we at Papahanaumokuakea Marine National Monument often open our meetings with this. One is that we want to have a singular purpose that we can have some focus in our meetings. The next line, Aveloana I lehua la'ea. Everyone say Aveloana. I lehua la'ea. Good. So you can see as the sun sets in lehua, but the word velo is something, a really interesting word in Hawaiian. It can be translated as set, it can be translated as to flutter, as a flag. But another level of meaning to that, it speaks to a family trait. Kui kavelo, someone has a particular family trait. And it's a good thing that you're reflective of your parents and your grandparents, right? And I think our presenters today very much likely reflect that as well. He waialoha kamakani la'ea. Everyone together, he waialoha. Kamakani la'ea. Very good. So as you see our archipelago there, we started at Kumukahi. We even have it marked on the map. We went to Lehua, which is an islet right next to Ni'ihau. And now we're passing there and we're off to Nihoa. And the wind of Nihoa is called Waialoha. Here in Hawaii, we name our winds, our rains. They're fond, sort of part of our family and our landscape, one and the same. So Waialoha is the name of the wind, and you probably heard the word aloha before. And so Waialoha can be translated as waters of aloha. And that's another thing we want to bring into our meetings. And it's not necessarily like a, kumbaya, let's all feel good kind of thing, but let's have some compassion for each other. And aloha means that, compassion or empathy. The next line, O Hawaii loa, kia lahula la'ea. Everyone together, O Hawaii loa. Kia lahula la'ea. Not bad. Most people get really hooked up on those. So Hawaii loa is the channel between Nihoa and Mokumanamana. Just as we name our winds and rains, we also name our waters that we traverse in order to get between the islands. The waters that connect our islands, really. And then if we shoot furthest to the west, we come to Kure, and in Hawaiian the name of Kure is Holaniku. And so the next line is Iholani ke kuina. Everyone together? Iholani ke kuina. Iholani ku. So Holani is saying that all is joined with Holani, and that's actually an old saying that all the islands are connected to Holani and heading off in our westerly direction. Holani is also the name of the zenith, and so we have more sort of images of sun throughout this chant. But it's the reason that's an appropriate image for this sort of occasion is that Holani, the zenith is, in Hawaiian, we consider it a place where things come together. The zenith is where east meets west, north meets south. The zenith is where morning meets afternoon. So it's very much a gathering as we have this morning. So we have that. I'm going to have my colleagues come on up and join me. But there's part of this that I'd like you folks all to be able to participate in, and that's the clap that goes along with this chant. There's two claps, two types of clap. I'm going to put this down for a second. Hello, good morning. Okay, you can hear me, sort of. So there's two types of clap. The primary clap is with sort of cupped hands. Everyone clap? Very good. So this is called kilipo'i. To do this is upoho. You don't have to memorize all this, but there's a particular word, and so we clap, especially for when we have an intention like this. Oftentimes our chants are accompanied with a clap. So this is the primary clap we're going to be doing, and you can work with us to get the rhythm. Before we start, I'll have everyone stand up and we can do this. But the last clap that we have, so we just clap this way, we keep rhythm, we'll chant, and then the final clap is like this. And you'll see us at the very end, we'll say Iholani ke kuina, Iholani ku, and we'll just do that. Okay? Not too challenging, right? So everyone clap. Okay, and then the pa'i, that's how we're gonna end. If you're the one who does an extra clap, we have a special prize for you. So we're gonna do it 3 times. That way everyone can, you can slowly get into it. If you feel particularly brave this morning, go ahead and start, doing the words. By the 3rd time, you feel like you can get it. So anyway, how about we all stand? And Naida's going to start us off, and we'll do the chant, and everyone clap along. Last time. Pretty good. Have a wonderful day, folks. Okay, since we're learning names, I'll have them introduce themselves.
Aloha mai kākou, my name is Nadia Lewis, and I'm the Partnerships and Outreach Coordinator for Papahana Mokuakea.
Aloha everyone, my name is Kanani Medeiros, and I'm the Strategic Initiatives Associate for Papahana Mokuakea.
Aloha mai kākou, my name is Blaine Benavides, and I'm the Native Hawaiian Program Specialist at Papahana Mokuakea. Have a great day, everyone.
Aloha, I'm Pool Borges-Smith, and I do permits and policy at Papahānaumokuākea.
So, this is our 2014 Summer Intern Symposium. It's about our 4th year of operation, and one of the first things I want to do is probably give a quick sales pitch to our internal, well, I guess secondly. First, this is our list of presenters today. We have a lot. We have more than last year. We have 17 presenters. We have 4 sessions. Hopefully you can stick around all day. We'll be going to 4 o'clock, sorry. I know a lot of people leave at or around that time. Please try to stay around for the whole day. They're from all over the country, as you can see. As we work through the day, you'll hear more about their schools and where they're from and what offices they're working in. This isn't quite up to date, but this is the sales pitch I want to talk about, the PYSO program here at Pacific Islands Fisheries Science Center. PYSO stands for PIF's Young Scientist Opportunity, and it is a paid internship over the summer. It's run totally internally here at PIF's. It's modeled loosely after the Hollings program, which is really great, but it's something that we call our own PYSO, and there's 4 of them in the room, and you'll hear their talks today. So spread the word. If you know anybody that's a sophomore or junior, undergraduate level, please point them towards PYSO. You can find it on the web very easily. Just Google PIFSC, PYSO. We have quite a few people helping run this program. A lot of them are in the room helping to get this symposium underway, being moderators and doing other tasks. It's run by the Joint Institute at the University of Hawaii. A little later in the morning, we'll have a short talk by either Jeff Hare or Mark Merrifield from JIMAR. Right after I talk, I'm going to have Sampuli give a brief introduction. This is how our summer internship symposium has been going over the years, and I apologize to those of you that were here or at Dole Street or were at UH last year for the symposium. I'm going to recycle some of my same jokes. But in a way, I saw this graph looking at the number of presenters we had every year, and being a scientist, I immediately tried to fit it to a model. And it fits really well. It's amazing when we use the data, of course, up through last year. What this model predicted was by 2025 we'd have over 200 interns. And you'd have to be kind of older to get this joke, but maybe even some of the younger people have seen the movie Jaws. We definitely needed a bigger boat last year, so we got a bigger boat. We have this amazing room, this amazing facility, and unfortunately, in 2014, we did improve. We got 1 more intern than last year, but we weren't quite up at the 20s level that the model had predicted. And I blame that on the government shutdown and sequestration. I think we'll go back to the model line in subsequent years.
But it's encouraging. The young folks always impress us. I'm positive that's going to happen again today. And JIMAR is really happy that we can be part of this process. It's a NOAA funded, it's a center funded activity. The PYSO program is. And then all the Hollings scholars and the other students that are here, congratulations on what you've been able to accomplish in such a short period of time, and we look forward to the presentations.
Thanks, Jeff. I'm going to walk over to where Sam is. While I'm walking, I just want to add something. As you go through your careers, you're going to grapple with this balance between the what you know and who you know. And I'm kind of cynical at this stage of my career, and I think it's about 80% who you know and 20% what you know. Today we're going to hear a lot about what you know with all the great science, but as far as the who you know, this is a great opportunity. What you see in the room here, there's a lot of who's in this room. Please use this opportunity to network. Hopefully a lot of you brought your business cards. Please distribute them. Use social media. And here is Sampuli.
So I'm totally cynical too, and I think it's what you know, not who you know. It was interesting to see the sanctuary program start off this morning with a little traditional ecological knowledge of the Hawaiian Islands. It's something trying to look at the interplay between traditional ecological knowledge, TEK, and what I'll call Renaissance science, which is what most of the natural sciences are, and to a certain extent the non-natural sciences, the social sciences, and I guess there's other sciences, but anyway, those sciences. But most of the papers here are in the natural sciences, and there's a lot to be learned from traditional Hawaiian ways of looking at the ocean, but also, of course, from other cultures, from Japanese and Chinese, and those people who were close to the land. Another thing that you do in Hawaii is you give your genealogy, and I'm going to give mine really briefly. My great-grandfather was a pauper in England and lived in a mud hut. And so I was about as close to the land as you can get. And so now I live in Hawaii. So I have seen some of you, most of you, around over the last month or two. I didn't really have a clue who you were. A couple of you stopped in and said hello, and I appreciate that. So now I'm going to get to know you by not who you are, sorry, Don, but what you have to show us. I think it was good that Don gave a traditional federal government presentation there, because I know all of yours will be so much better than what we can do. And in fact, I think, Don, we should suggest that next year that the interns give a seminar to us on how to do presentations, because you stick to the point, you get, I mean, assuming you're going to meet last year's standard, and I'm giving you some expectations here. You stick to the point, you get it done on time, and I'm really impressed with the capability compared to, frankly, what some of us have done in the past. Myself, not only included, but perhaps Premier Chris Boggs is having a good laugh. I'm really looking forward to this, and I hope to make it through 4 o'clock, although I might sneak away and look at my device at various times. Luckily, this room has really poor reception. This is a brand new modern building. They don't seem to understand that the modern world requires wireless. But I will say the one thing, oh, hi Steve. He wasn't responsible for building the building, he was just responsible for operating it. So he will be fixing all these things. And next year when you come back as graduates, you will find everything working fine, because Steve's been a good partner. So just to remind you what the mission of the Science Center is, and this is kind of, we ought to tell you on your first day, not on your last day, is we want to have timely, high quality, applied scientific information for conservation and management. We don't do the conservation and management. We want to provide the science to the agencies that do the conservation and management. We want to maintain that separation so that the science has integrity and independence, and isn't frankly corrupted by the management process. Sorry, managers, if any of you are in here. And of course, they don't want us picking on in their arena too, even though of course we know better how they should be doing their jobs. Somehow they seem to think they know better how we should be doing ours. So we're going to learn today how to do our jobs better, thanks to you, and look forward to it.
Thanks, Tom. And I forgot if I mentioned this, but I'm a biologist at NOAA Fisheries, and this particular duty is one on a long list under the category Other Duties as assigned, and it's actually one of my favorite duties, so hopefully I keep getting to do this because it's a lot of fun. We're going to start the symposium now, and the moderator for our first session is Chandel Brunson, and she'll be coming up here. The first talk is a little bit different from the rest because it's going to be a joint talk using a double time slot.
Okay, so as Dawn mentioned, my name is Chandel Brunson, and I am with the Turtle Research Program here, Pacific Islands Fisheries Science Center. So I have the pleasure of introducing the first 2 presenters that will be presenting together. Their mentor was one of my coworkers, T. Todd Jones. The first one is Christina Wine, and she's studying at the University of Hawaii at Hilo, studying marine science, and she's with the NMFS PYSO program. The title of the study is, or their presentation is Energy Flow Through Biological Systems, and it'll be 1 and 2, like Dawn mentioned, that'll be combined. So the second presenter will be Olivia Hughes, and she's from Washington College, and that is actually in Maryland, I just learned, studying biology. and she's also with NMFS with the NCCOS program, both again studying with T. Todd Jones, energy flow through biological systems 1 and 2.
So Christina and I are lab partners, so we're working on the same projects. So we're giving the presentation together, but we're both working on all of these projects.
Where do we begin? With just an overview of the 5 projects that we've been working on. Okay, so the first is Hawksbill foraging energetics, and we're looking at diet items of Hawksbill turtles, trying to figure out some things. We'll go over it later. The next is overwinter snacking of leatherback turtles as they're in Hawaii. Next is the energetics of green turtle nesting migrations as they migrate between the Monument or Northwestern Hawaiian Islands and main Hawaiian Islands. And then energy flow into deep coral communities with Frank Parrish. You see him there, he's pretty cool. Then we're also looking at the energetic strategies of juvenile loggerheads that are in the central North Pacific and the eastern tropical Pacific.
To give you an overview of our methods, we do the same process with all of our samples for all of these different projects. So we start out by putting our samples in the oven at 80 degrees Celsius until it reaches a stable mass, so we can have a dry mass. Then we ash them in the muffler furnace, and we also run oxygen bomb telemetry on them to get the energy content of each sample. So when we ash them in the muffler furnace, we are determining the residual, whatever is left over after it's been ashed at 600 degrees Celsius for 6 hours. That is the content that is not available as energy for organisms.
Okay, so back to the first project in more detail. The reason behind this project is because we were wondering why, under the same protections enforced at the same time, where green turtle populations, they're nesting, you can see their nesting populations there, increasing, they just took off and they did really well, while hawksbills were pretty much not being helped at all. And we were wondering if they might be forage limited. Across the globe, if we look at, like in the Caribbean, hawksbills are doing pretty well. They're robust animals and they're eating a lot of sponges. In other places they're eating seagrass, sponge, coral, mangroves where there are mangroves. But in Hawaii, we don't really know what they're eating. And from observations of hawksbills, most of them are swimming, but the forage observations that we've seen, or that we are taking in, reading actually doing, are some of them are, miscellaneous coral and a little bit 8% algae, but most of them seem to be looking for something in the coral, which could be sponges. And looking at gut intake, stomach contents of Hawaiian hawksbills show that they're eating about half algae and like less than half their diet is made of sponge. Whereas in the Western and South Pacific, they're eating a lot more sponges and less algae. So we were just looking at that and looking at the energetics of each diet item. The available energy, which we are determining by telemetry, that's the part where we come in, me and Olivia. We were able to look at, or also other data is looking at if you look at the total energy in a protein sponge, it's much higher than any of the others in a silica sponge. And then they took available energy by looking at sponges that had passed through turtles and comparing it to what pre-digested sponge. And if you look at it and bomb that and look at what was digested and taken in by the turtle, they're taking in very little energy from the silica sponges. Algae and tunicate they've yet to do. And it's very high in comparison with the protein sponges. So we were looking at that.
For the overwintering of leatherback turtles, there's 2 nesting populations on the Western Pacific and in the Eastern Pacific. And our project is focusing mainly on the Western Pacific. So they forage on the west coast of North America before migrating to Indonesia and the waters of Australasia. And they're overwintering, if they're not nesting, they're overwintering here in the Hawaiian Islands. And originally it was thought that the Hawaiian Islands was blue water that was a very dead zone for them energetically. And recently, recently from gut contents of juvenile leatherbacks, gelatinous mass in their stomach was found, and it was bomb calc, and it was very high. It was much higher than any of the other diet items that they're known to eat when they're foraging on the west coast of North America. And so we didn't know what that was. From pyrosomes that were collected, we know that pyrosomes are very high in energy and they're also gelatinous. So this might be the missing link. So the Hawaiian Islands might not be an energetic dead zone for these animals, and they might indeed be foraging here. So we've completed some plankton tows in search of pyrosomes. We have not yet found any, but we did have pyrosome samples collected from the Hawaiian longlines and given to us. They were dissected from the stomach of a lancet fish, but that was north and south of Hawaiian Islands where these leatherbacks are known to be found, because the Hawaiian longlines have also caught these same leatherback turtles, and these pyrosomes are in these areas, so we know that that is a possibility of what they could be eating.
Okay.
For the energetics of green turtle nesting migrations, we have the opportunity to have a clutch of green turtle eggs. And by having these eggs, we've dissected them into the shell, the yolk, and the albumin, so we can get an idea of exactly how much energy is in each part of the egg. And by knowing how much energy is in an egg, we get an idea of exactly how much energy is in a clutch of eggs. And knowing that green turtles nest about 3 to 5 times per nesting season, we can have an idea of exactly how much energy is required for these turtles to nest in one season. We also have hatchling turtles that we've had the opportunity to run energetic analysis on. And the yolk from their stomachs, the residual yolk, which gives us an idea of the parental investment into each turtle. And they all have different amounts of yolk, but the higher the residual yolk in the stomach of the turtle, the farther that they can migrate offshore to feed, and so they have a higher probability of surviving. And so by doing energetics on all of this, we know exactly, well, not exactly, but the reproductive output of a female turtle and what she'll need before she can migrate.
And we have some hawksbill hatchlings too that we were able to look at with the yolk in their stomach. All right, and then the next project, Energy Flow into Deep Coral Communities, is with Frank Parrish, and he works with Hawaii Undersea Research Lab and uses manned submersibles to look at real deep, deep corals, where the only thing that falls down to them, which he has analyzed and found that there's hardly any energy in, is this pelagic snow that falls, which is like the detritus and waste that falls down from the upper layers because there's no sunlight where they are. And he's also able to measure and sample at the end of a measurement period the growth of these deep corals, which are slow growing and long-lived. And so we have the opportunity to get some of the coral slime that grows in the corals, the organic matter, and we're going to run analysis on that. We haven't begun yet, but we will. And he's also looked at some of the snow that has trickled down. All right, and the last project that we haven't begun yet, but we can and will, maybe tomorrow. Our internship's a little bit offset from the Hollings. Is looking at the loggerheads. As if you see the sizes of the loggerheads are not just because they're cute, they're meaningful. I meant to remove this slide. The baby the baby loggerheads are swimming over, they're migrating over from, or not migrating, they're coming over from Japan. And they come up, if you look at the red and the blue, it's a density graph kind of the probability basically of finding a loggerhead in those areas. So the darker colors are where they're found. And so as they are growing older and they come up, they either stay in the central North Pacific and they're eating, pelagic stuff, pelagic gastropods, decapods, amphipods, or they come down, they choose to come down to the eastern tropical Pacific where they're eating fish, which is maybe mostly bycatch from fishermen, and decapods like the pelagic red crab, and some of them exclusively feed on pelagic red crabs. And so we're just wondering why would some of them choose to stay, and why some of them would choose to go and head down. And so we're taking one step at a time, and because the questions are things like, well, are there just a lot of red crabs there? Is it easier to feed, or are they actually richer in energy? So we're taking one step at a time, looking just basically at the energetics of the red crabs, which we happen to have, and eventually other diet items, other interns, other summers, maybe we'll be able to look at them. But we have pelagic red crabs, and we're going to start to look at the available energy that is in each crab, or the average crab, to loggerheads.
We'd like to acknowledge Don for taking us out on the plankton tow and organizing the symposium, and all of the other people that have helped our mentor T-Todd collect samples that we have the opportunity to analyze.
Mm-hmm. Yeah, thank you very much.
Are there any questions? Yes.
Well, you mentioned the collections. How do you get the little dead baby turtles to
We purposely said words like energetics of Hawksbill. Yeah. They have died in the nest, and the eggs were from a female turtle that was poached, and were inside for George Pelas, actually, in the turtle. Yeah.
So yeah, we have a lot. We have Hawksbill and we have green turtle hatchlings that didn't make it. They had passed away before making it to the water.
It's pretty sad, actually.
Couldn't there be a bias because they're dead, not maybe they died of starvation?
Yeah, there could be. We're not sure, but because they're protected species, we can't take turtles.
And so you took careful note of that yolk, which sort of suggests they're not starved.
Yeah.
Yeah, but I'm saying if you found one that had
Or a crash or something, or weakness. Yeah, we don't know.
Yep.
Keep in mind that the shell eggs from the green turtle, that turtle had to, if it would have lived, it would have nested on Oahu.
Mm-hmm.
It would not have been a migrant turtle. So I don't know if that calculates into your formula or not, but because it was shell, there's no way it could have gotten French frigate shoals to nest.
Yeah.
The legs in.
Yeah, that turtle is from Honolulu.
We actually have a good bit of time still, so we're encouraging questions. Feel free to
I don't know if I did some fine energetic work on tunas, which were red crab were one of the diet items. I think Bob Olson might have measured their work.
Oh.
If you look at that paper.
Okay.
But he brought them out to us to do gastric evacuation rate studies, and the tuna here would jump on them like they gorge on them in the Eastern Pacific, and then the tuna here would spit them out.
Oh.
There'd be a single one. So this is kind of whimsical, but maybe Central Pacific animals just don't like red crabs.
That's a good point.
They're kind of nubbly.
Mm-hmm.
Any more questions? There's a question.
Yeah.
How much longer do you guys have on y'all's internship?
It's about a month.
You guys have another month?
Yeah.
You're coming back 4 more years to do the other 4 parts.
And one thing I didn't tell anyone yet, but I'll start here. After your talks and the questions, please spend about a minute or so telling me what your future is from this point forward, both of you. Plans, short term, long term.
Well, I'll be a senior in the fall, and after graduation, I've really applied for the Peace Corps. I'm not sure. Working with fisheries, but I'm also applying to grad school and maybe jobs.
That was a long minute. I'm going to go back to school too in Hilo and study marine science. And after I graduate, I really just want to work on a boat somewhere. But after this, maybe, I don't know, head back to science, which would be good.
And if it wasn't clear who is who, because I had kind of introduced them, but they didn't stand up.
I'm Olivia.
The lady on, yes, on the right is Olivia, and this is Christina.
Actually, I'm just kidding.
Are there any more questions?
Who's from UH Hilo? Okay.
I've heard of you, yeah.
I have a very constructive suggestion for everybody. put your email address somewhere in your PowerPoint slides, because I'm gonna ask you afterwards, what's your email address? And if it was up there, we could just.
Okay. Sure. Thank you. Thank you.
Okay, so the next presenter is Teresa Withee. She's from Bowdoin College in Maine, studying economics. She's a Hollings scholar. Her mentor is Emily Gaskin. And the project title is The Value of Economics, Assessing Coastal Blue Carbon in the Hawaiian Islands. So, Teresa?
So hi everyone, I'm Teresa. This summer I spent my internship with the Hawaiian Islands Humpback Whale National Marine Sanctuary under the guidance of Emily Gaskin. And as an economics and environmental studies major at Bowdoin, I was interested in looking at how economics can be used in the prioritization of marine resources. So a little bit of background about the sanctuary. As the 12th established one in the nation, it lies within the shallow waters between the main Hawaiian Islands, shown in this map here. And it constitutes one of the most important humpback whale habitats in the country. They play an important role in promoting ocean stewardship to visitors and residents alike, and in enhancing awareness about the sanctuary resources. Now it's soon going to be transitioning to an ecosystem-based management approach. So this means I will be considering the ecosystem as a whole rather than just focusing on the humpback whales in making their decisions. So my study sought to answer two questions. First, and most importantly, is this type of assessment on the economic value of coastal blue carbon a valuable policy tool for the sanctuary? And secondly, what is the economic value of the carbon dioxide stored in salt marsh and seagrass in the main Hawaiian Islands, considering, of course, the data, the extent of seagrass and salt marsh coverage, and the parameters that I set. So a little bit of background. Green carbon refers to this carbon that is stored and sequestered by terrestrial forests. And this is well known and accepted by scientists. And as climate change is becoming more of an issue and we're trying to address CO2 emissions, many programs have become established in order to provide funding opportunities for countries, communities, and organizations that will preserve the carbon sinks that these forests provide. Now, coastal blue carbon is significantly less well known as it's a relatively new idea. It refers to the carbon that is stored in seagrass meadows, mangroves, and salt marshes, which are all three very important coastal ecosystems. Now, currently, these ecosystems are net carbon sinks, meaning they store more carbon than they emit. However, if degradation and conversion continues, they'll become net sources of CO2, releasing the carbon that's stored in their sediments in the atmosphere over time. In 3 out of the 4 ecosystems shown in the figure, which displays tons of carbon dioxide equivalent per hectare relative to tropical forests, it's shown that more carbon is stored in these ecosystems, in their soil, sediments, and biomass than is in tropical forests, which lends to the question of why aren't we recognizing this resource and taking advantage of it. And additionally, in all 3 ecosystems, the majority of the carbon that is stored in them is stored in the soil sediment. And so 95 to 99% of the carbon stored in seagrass and salt marsh is actually stored in the soils. Sorry. So economics is really important, especially in this study, because incentives drive almost all human decisions, whether it's the burning of coal because it's cheaper than the alternatives, or developing coastal property because it's more profitable than letting it sit idle. As of right now, we lack the incentives not to convert coastal property. While the preservation of forests is incentivized through programs like the UN's RED program, there exists no such program to incentivize the preservation of these coastal ecosystems, which are among the most threatened in the world. And the problem ultimately is that ecosystem services and the benefits they provide, such as storm protection, carbon storage, and biodiversity, are not exchanged in markets, which makes it difficult to consider them in decision making. However, this problem can be addressed by putting an economic value on the carbon dioxide that is stored in these habitats. This can then inform policy management approaches, and education. Now, onto my methodology. The method I used to estimate the total economic value of blue carbon in salt marsh and seagrasses in Hawaii was emissions avoided. Essentially, this entails projecting the CO2 emissions in the case of habitat disturbance over a certain time frame, and then calculating the present value of keeping this carbon intact. Now, because specific values for the carbon sequestration rates and the amount of carbon at risk in these habitats in Hawaii doesn't exist, I took values and the method of calculating the blue carbon benefit from the report titled Green Payments for Blue Carbon, which came out of Duke University's Nicholas Institute. Of course, in doing this, I had to assume several things. First off, that the rates and the values the report's authors produced are general enough to apply to the habitats in Hawaii, and then additionally that the author's research is thorough enough that I can trust it and use it in my own research. So what parameters have I set, and what do they tell us? First is the discount rate, which is probably the most important and the most controversial component of any economic assessment, especially one that deals with benefits that you receive so far into the future. It's essentially a way to measure how we value future money in the present, and at its core is how much we emphasize the welfare of future generations relative to our own welfare. So although I've used 3 discount rates in this study, the one that I really emphasize should be used is the lower discount rate of 3%, because in studies it's been shown that Pacific Island inhabitants, they consider the next 5 generations when making decisions and planning for the future, whereas all other regions only consider the next 3. Additionally, because Hawaii is a state in a very developed nation, management of these resources is certain. So the time frame in the study, they used 25 years, so for simplicity's sake, I use the same time frame. And then the carbon price, I wanted to use 2 levels to show that as the carbon price increases, the incentives to preserve these habitats also increases, which sounds very intuitive, and it is. I got the $7.78 from the European Trading Scheme, and this is the current carbon price of 1 ton of CO2 on the market. And then I used $15, which the study also used in their calculations. So I used 2 equations to calculate the values that will be used to calculate the total economic value. So first you have the greenhouse gas benefit flux, which looks really confusing, but really separated into its 3 components is quite simple. First, you have the carbon sequestration rate for each habitat, and this is assumed to be constant, because assuming that the habitat is preserved, it will continue to sequester carbon annually. Secondly, you have the CO2 emissions avoided for each habitat, and this changes over time depending on how quickly the carbon is converted to carbon dioxide and released into the atmosphere. And then finally, you have the methane emission rate. This is also assumed to be constant, and it's only applicable for salt marsh. So then using this greenhouse gas benefit flux for each year from time 0 to 25, I could calculate the blue carbon value for each of the habitats, and this is in units of dollars per hectare. So in this first table, I just wanted to show my initial data that I used. This shows the total carbon at risk, which is the soil and biomass combined, and the carbon sequestration rate for each habitat. And then below is where the interesting information is. I calculated 6 blue carbon benefit values, but 3 of them are the ones that I'm going to use in my final calculations. So first I've highlighted the very conservative number, and this is using a 10% discount rate and the $7.78 price level. Next, I have a very high estimate using a 3% discount rate and the $15 carbon price. And then finally, I've highlighted the value that in my opinion is the most appropriate one, using a discount rate of 3% for the reasons I stated earlier, and the carbon price of $7.78. And then also notice one interesting thing is that the difference between the blue carbon benefit per hectare for salt marsh and seagrass isn't very different, because salt marsh carbon is converted to carbon dioxide at a much slower rate than seagrass, and because of the discount rate, it's not valued as much. So where did I actually end up looking? Because data on the Northwest Hawaiian Islands wasn't very accurate, I decided to just focus on the main Hawaiian Islands. And then actually, how much coastal blue carbon is there? I excluded mangroves from this study because they're an invasive species, and so overall they do more harm than they would do good by storing carbon. Then onto the area, I was able to use GIS with the help of someone in the office, and we found that seagrass is very rare in Hawaii. There was only one patch in the data, which amounts to 2 hectares. There was a bit more salt marsh. We estimated it to be 68 hectares using line data from the Environmental Sensitivity Index and then estimating it with a width of 20 meters. And already you can tell that salt marsh is going to be much more valuable overall than seagrass because it's much more extensive. Now is the most exciting part of my study, where I've actually calculated the total blue carbon benefit values for seagrass and salt marsh. And again, I've highlighted the number that I think is most appropriate for them. In fact, these results aren't very exciting because they're both very low, although salt marsh looks like it's really high at $431,000. It's still low relative to other studies that have been conducted. So before we get into conclusions, some important considerations. First is the lack of accurate and quantitative data. We know that there is more seagrass out there on the main islands and especially in the northwestern Hawaiian Islands, but because the data doesn't cover this, the number that I've come up with is a severe underestimation. Secondly, this project doesn't consider the cost of management or the opportunity cost of preserving the habitat, which would have a huge influence on whether preserving this is actually economically viable. Additionally, carbon prices fluctuate very vastly. This graph below shows the price of 1 ton of carbon dioxide in the EU trading scheme from January 2008 to February 2013, and it ranges from 5 to 30 euros. And the price that I use in my study is actually at one of the all-time lows. And then finally, of course, economic analyses are inherently subjective, and the parameters that you set make a huge difference on your final results, which I hope I illustrated by using 3 discount rates and 2 different price levels. So to answer the questions that I proposed at the beginning, the numbers that I calculated suggest that there are more effective ways that that the sanctuary specifically can guide its decision-making and inform management of coastal and ocean resources. This could include other ecosystem values, other ecosystem services. A recent study released by NOAA estimates that the total value of coral reefs in Hawaii is $33.57 billion, which is enormously much. It's much larger than the value that I calculated for the carbon storage. And although these results that I've gotten may suggest that a more thorough investigation into coastal blue carbon in Hawaii isn't valuable, it does provide an important educational tool to enhance awareness about the marine environment and ecosystem services in the state. And I'd like to thank my mentor, Emily Gaskin, David Graham from the Monument, who helped out tremendously throughout the whole project, and Joey Lucky, who basically dealt with all of the GIS that I worked with, and the entire sanctuary staff that I got to meet and work with.
So if you have questions, we're going to ask that you ask them in the microphone so the people on the WebEx can hear you.
I've got such a loud voice, do I really need it? Oh, you're first. No, she beat me. Go ahead.
Thanks, that was really interesting. Do you have an explanation as to why the price of CO2 has dropped so much since 2008?
I actually don't know. I imagine part of it is probably due to other situations in the market globally. So I don't know if something happened in around 2008, 2009, in the middle of the recession. But I imagine that influenced the price and made it more expensive. Also, I know that the European trading scheme has entered its second phase, so I don't know if that also affected it. I didn't look too much into it, but.
Yes, that was fun. It's good stuff to think about. I do a lot of kayaking through mangroves, so I really would have been interested to see what your sequestration rate would have been for mangroves. I understand why you didn't do it, but the amount that we have,
yeah.
You know, when you think about seagrass, a couple things. I mean, the species of seagrass you're dealing with as your parameter, the long, big, and we've got Halophila hawaiiana, it's about this big. Yeah, so is there any difference in, you know, what the sequestration would be regardless of the size of the patch, but what the actual animal is? I mean, our seagrass is a lot smaller.
Yeah, there was a study that looked at seagrass in the Mediterranean, and they do mention that the species changes the carbon sequestration rate and how much would actually be stored. So that, I realized, was a stretch in taking the data that they used, but there wasn't any data available for the Hawaii endemic species.
Do you know if there have been any studies done looking at the sequestration value of phytoplankton?
Well, we considered looking at smaller organisms like that in the ocean, but then after I briefly looked into it and didn't find much on it, and a lot of the literature, even though there isn't much literature, is just focused on these 3 ecosystems that I identified. But I imagine they do. They're probably studying somewhere.
Yeah, the mangroves. This is a sensitive point for me. An invasive species, yet you go to Fiji, you go to anywhere else in the world, and mangroves are cherished, protected. Would you care to comment a little bit more about how they do more harm than good in storing carbon? And anything along those lines?
So I sort of flip-flopped a lot on whether to include mangroves, because I realized that they are the most extensive carbon sink, I'll go way back to that. They store and sequester a lot more carbon than either of the 2 habitats I looked at. Hold on, there. And so that's why I figured it could be interesting looking at them and seeing the economic value that they provide and how much they're worth, because I do realize that there are a lot of organizations that I found in researching mangroves in Hawaii that are trying to eradicate them. And although they do help with like water clarity and providing habitat for species in other regions, here apparently they're a huge threat to certain endemic species of birds and fish. And so I figured that it would just be a whole other branch of this project to look at, and that it wasn't worth it because of that issue.
Yeah, it'd be interesting about the the database for being a threat to various species, but this is not the time and place to go into that. I would just say that the manner that mangroves are exterminated using the basic compounds of Roundup and then letting the logs fall right there on the spot and never removing them is a disgrace in itself, and I might add, using federal funds to do it. Sorry about that. Thank you. Very good that you brought that out. I'm very impressed that you brought up the topic and said it. Thank you very much.
So the salt grasses and I guess, so these habitats have a lot more value besides coastal blue carbon.
Yes.
And so, for example, you mentioned that study on Hawaii's reefs being valued at whatever, 37 billion, something like that. I'm wondering if you know if there's any efforts to quantify the total economic value that these coastal habitats provide, including blue carbon as a component.
Blue carbon is definitely not included. Nowhere in any of my searches did I find anything at all about valuing these ecosystems for the blue carbon role that they play, and specifically in Hawaii. There have only been some studies in North America, the Philippines, in the Mediterranean and Europe. But on the topic of if they're valuing the other benefits derived from these ecosystems, I'm not sure if they're doing that. future, I will finish my senior year at Bowdoin and then hopefully get a few years of job experience in the field, looking at how environmental economics plays into policy, and then hopefully go to grad school. I have no idea doing what, but that's as far as I know. Thank you.
Are any of Teresa's mentors in the room to say a few words? Yes?
Good morning, everyone. I'm Emily Gaskin, and I was Teresa's primary mentor for this project, and I'm thrilled with the work that she's been able to do this summer. I think that she was really able to take her 2 degrees and integrate them in a way that was really sophisticated. And what was so interesting about this study for the sanctuary is that we had this as a research question. We were curious about blue carbon, but we really didn't know what the results were going to say. And as Teresa went through this process, she found that the numbers were actually very low when compared to other ecosystem services. And I think that one of the most interesting outcomes has really been her ability to assess the methodology moreover than the results, because I think that this has a lot of interesting policy implications. Often in the South Pacific, we're being compared to other islands, or in the Pacific, we're being compared to other islands, and some of them have come out with astronomically high numbers for their blue carbon rates. And I think it's a really interesting economic exercise to be able to illustrate that that's just not applicable here, and that shouldn't necessarily be part of the conversation. It's also saved David Graham and I a year of trying to do a far more comprehensive study, so we're very grateful for her 9-week mini study. But if anyone is more interested in this topic, we'd be happy to follow up with you, and thank you for taking the time to be here.
So our next presenter is Alissa Phillips. She's from the University of Akron in Ohio, studying biology. She's the NOAA affiliation is OAR. She is a Hollings scholar. Her mentors are Aidan Colton and John Barnes. And her project title is Mauna Loa Observatory and Climate Change. And I would also just like to mention that Jaimar actually flew her in from the Big Island, so she could be here today. So, thank you.
Hello, my name is Alissa. I'm from the University of Akron. I'm actually studying towards a secondary education license for biology and physics, also a bachelor's in biology and a minor in physics. So I've been fairly busy. Next year will be my 5th year. I'm working with the Mauna Loa Observatory. They're with Oceanic and Atmospheric Research, and one of their missions is climate adaptation and mitigation, basically doing public outreach and working in a classroom. My mentors are Aidan and John. They couldn't be here today, but they've been really helpful through the process. Mauna Loa Observatory is located on Mauna Loa on the Big Island. It's the mountain itself is 13,678 feet. The observatory is at 11,141 feet. And they have 3 buildings, 3 large buildings and smaller domes that house up to 250 pieces of equipment. They do everything from measuring carbon dioxide, methane, carbon monoxide, water vapor. They have a device for everything. They also receive funding outside of NOAA. They get a lot of companies that will come in and say, hey, we'd like you to do our research for us. We will pay to set up all the equipment as long as you can go in and monitor our devices for us. So one of the big roles that my office has, it's a very small office. There are 7 workers there year-round. And every day they alternate who goes up to the mountain, and they perform daily checks on all the equipment. So basically they're the technicians. They go in, they make sure all of the equipment is running smoothly in order to collect accurate data that is then sent to Boulder, Colorado to be processed and gathered as a part of the climate change debate, all of the data for that. So Mauna Loa was first opened in 1956, and they started with solar radiation measurements. And in 1958, they began the longest running record of carbon dioxide. That was started by Charles Keeling from Scripps, and that was when he first decided to look at carbon dioxide. And within the first year of looking at carbon dioxide, he noticed that it is cyclical, diurnal, where in the one half of the year carbon dioxide is much lower, and then the other half of the year it's much higher. But he also noticed within that first year that it was still increasing even though it was cyclical. So they do a lot of outreach. They have a lot of tours that come through, mostly the scientific community. I was privileged to work with 40 sixth graders from Boulder, Colorado, who they flew to the Big Island just to get a tour of the Big Island. So I was very privileged to get to work with them and tour them around, tell them what the observatory itself does. But my purpose is actually to create lessons that can be taken into the classroom so that Mauna Loa can kind of spread its word. A lot of people believe, you ask them what people do on top of Mauna Loa, and they tell you that they do astronomy. But that's because Mauna Kea does a lot of astronomy, and we actually do have it. We have 2 telescopes on our mountain, but we aren't affiliated with them. So as a result of me working with the Mauna Loa Observatory, I've also been able to kind of create some collaborations, which I'll go into later. But I kind of I had a good amount of work, and I had a lot of experience out in the field, but I was able to create affiliations with Mokopapapa, which is it's the Educational Outreach Center for Papahanaumokuakea, and so I'll go into that later. So my objectives were to create lesson plans for 6th through 12th graders on greenhouse gases, chlorofluorocarbons, and aerosols. These are all things that are studied up at Mauna Loa, and part of each lesson plan I would come up with an activity so that students were better able to understand what these were. So the goal was to increase student interest, increase the public awareness, and to teach stewardship. Being on the Big Island, and it's a very different culture. So when you're there, you see a lot of people who recycle, a lot of people who will go out and just pick up trash. I became scuba certified, and my dive instructor, he would go out and pick up lead every time he would go, and it was a really enlightening experience to see that there are people who actually care about the land and the water. So my personal objectives coming to Hawaii and working at Mauna Loa was to understand the science. This is a picture from the solar deck looking across to Mauna Kea. I took this with my GoPro. I also wanted to broaden my knowledge base. I know a lot about climate change, but I didn't know the specifics on how the data was being collected, where it was being collected, and if there were any variables that would come into effect when it came to analyzing the data. I also wanted to gain technical experience. I worked with the National Weather Service to launch ozone sondes, which this balloon increases up to 10 times its size as it rises into the atmosphere, and it collects data. It has an intake where it collects air, and then as the balloon expands and it increases, the balloon pops and it comes down. So it's taking in oxygen, air from the ascending and descending of it. So that was a really cool opportunity. And I also wanted to gain teaching experience, but unfortunately it's the summertime and not a lot of students are in school right now. So like I said, 1956 was the year that Mauna Loa opened. This is the Keeling curve. As you can see, it oscillates every year, every season, as a result of the Earth breathing. So during the summer months when we're getting more sunlight, there's less CO2 in the air because plants are taking in more CO2, so it's not available in the air. And the peaks where it's higher is when we have less sunlight. Plants aren't able to take in the CO2 because they need sunlight in order to perform photosynthesis. So this is what they say when you can see the Earth breathing on the curve. It's a baseline facility. There are 6 facilities considered baseline. They're close to the same longitude. There's one in Barrow, Alaska, one in Trinidad Head, California, American Samoa, South Pole, and there's one in Greenland, which is not in the same longitude. But basically the goal of these facilities is to get the cleanest air that you can possibly get. They're so isolated, the Big Island is isolated from major pollution sources, so the air that we get that comes over the islands, it takes 2 days to get there, and it's well mixed, and it doesn't have the opportunity to be polluted by anything in between where it came from and where we are. So, and the elevation of the observatory itself is so high up that there's an inversion layer where any of the gases that we emit on the island is trapped. So that does not contribute to our CO2 record. And like I said, there are hundreds of devices. They measure everything from agents that force the climate to change, and they also look at ozone with our Dobson spectrophotometer. So my approach, I needed to look at the education standards of Hawaii. All of these lessons would be taught in Hawaii because they do not have the funding to go outside of their town. And I looked at the state of Hawaii standards, and I saw that there weren't too many, and they weren't very accepting of the national standards that were being suggested. So after doing that, I decided to visit certain outreach centers and NOAA facilities. So I went to Mokopapapa. So they teach about the coral reefs in the sanctuary at Popohana-Mo'okakea, and it's a very nice facility, and they put a lot of energy and time into making this facility. It's beautiful. I also went to Iniloa, the astronomy center, to observe several classes for 8th through 11th graders and kind of watch how the locals learn and what interests them the most. I also had to perform my own research with my mentor being out of the office very often and his boss being out of the office very often. I had to teach myself how to do a lot of stuff, which was a very good experience, but I was also able to come to them with any questions that I had or for clarification. I performed hands-on work up at Mauna Loa. I have gone to Cape Kumakahi, where we take samples. We have pressurized flasks that we collect. We collect air in that are sent to Scripps, and we also have flasks that travel in a suitcase, and you extend the pole 12 feet up, and those are sent to Boulder, Colorado to be tested for, I believe it's like 20, 21 various chemicals that are potentially in the air. They received 20,000 of those flasks throughout the entire year. And I had the privilege of implementing my lesson, fortunately, at Mokopapapa. I taught 6 lessons in one day. It was the same lesson, but it was a very stressful situation because we had 20 minutes per lesson, and we wanted to talk to them about greenhouse gases, CFCs, and aerosols. So we were very cram-packed into what we could do, but it was a very enjoyable experience, and I was really, really glad I had it. And with my last few days here, I'll be reworking some of my lessons to see what is beneficial for students to learn. So my collaborators were Iniloa. I got to work with them twice. Mokopapapa, there's a woman named Etta. She's the education coordinator. Very helpful woman. They're currently working to install a climate exhibit at Mokopapapa to talk about how climate change or carbon dioxide and ocean acidification, how those all tie together, and how what we do with our atmosphere relates to what happens in our waters. I also got to work with the National Weather Service and obviously Mauna Loa. And I'm here today, which is really awesome. It's a great opportunity. So my final product, I created 11 lessons for grade 6, because it's so hard to speak to 6th graders about something so large and conceptual. I wanted to talk about the weather versus climate debate and how basically start them young saying what weather is and what climate is, and how you can't use them interchangeably. Because even today you hear on the news or you hear in the public, oh, it must be climate change because it's 45 degrees outside or something strange, in the middle of summer. So that's one of those things that when you're working at a facility like this, it kind of irks you when you hear things like that. So I really wanted to clear up that for the younger students, and I was able to do that within the other lesson plans. So for grades 7 through 8, I created 3 lesson plans, one on greenhouse gases, one on CFCs, and one on aerosols. And I did the same for the 9th through 10th grade and 11th through 12th grade. Basically, I catered each concept so that the students would be able to visualize it a little better, because you can't use the same terms that you would with a 12th grader as you could with a 7th grader. And the last presentation I created was for Mokopapapa. It's a brief overview of everything that I thought was important, basically where Mauna Loa is, what they do, how it's different from Hilo, and how it's a very different atmosphere in that the weather is completely different up at Mauna Loa. The average up there, I believe, is 55 degrees Fahrenheit, and you're wearing pants and a jacket, and as soon as you get down to Hilo, it's about 75 degrees and very humid. So that actually is something with the reworking of my lesson plans that I've been able to implement into each one as a vast overview and an introduction to what we're doing. So Mauna Loa wants to go into the classroom and teach actual courses. They have been in the past participating in Earth Day every year, but because of funding, they have been unable to, and they have a very small staff now, so they can't man Earth Day. It's more like Earth Week, so they go for an entire week, and they have an entire building set up where students just come in all day. And unfortunately, they've been unable to do that. So they would like to create an outreach program, but they would also need an outreach coordinator. I might be a little biased, but I think I know somebody and I might be able to do it. So they would also like to make these lesson plans accessible for teachers. I had the privilege of meeting 2 school teachers from Boston and 2 school teachers from Pennsylvania, and they came up, they wanted to look at the observatory and kind of get a tour, and so I got to meet a lot of people. I'm not sure if anybody here knows Forrest Mims. He's a amateur scientist in Texas, very cool guy, older, and I had the privilege of meeting him. He comes up every year and stays for 2 weeks and lives in the observatory at 11,000 feet, and then every few days he goes down to the beach and showers and goes and gets some groceries, and then he comes back. So he goes and he calibrates his instruments. So I got to meet this guy, and he wrote a book on the history of Mauna Loa Observatory, and I got to get a lot of cool information from him and his insights on what the observatory does and how they do really good science there. So next steps for me, I'm going to finish both my bachelor's programs and graduate. I'll be getting married next summer. I hope to get a career in public or education outreach. I decided teaching is fun, but I would rather do it to people who really want to learn. So I would rather go into a classroom where somebody asked me to be there instead of being in a classroom where the students were asked to be there. It would just be a little more fulfilling. So I could be a high school science teacher, and I could also go to grad school. So I don't really know. So this is just a summary. Mauna Loa looks at the forces of the climate change agents that might force the climate. They would like to plan and implement an outreach program. And I created 11 lesson plans that will soon be reworked and hopefully posted to NOAA's website. And I gained a lot of hands-on experience, and I wouldn't trade it for the world. It was an awesome time. And I got to speak in a classroom setting to 8th through 11th graders on probably one of the hottest days there ever was in Hilo with no air conditioning, and it was a fun time. So yeah, I want to thank all the guys back at MLO, Forrest Mims, Mokopapapa, Iniuloa, the Student Scholarship Program for making this possible, and thank you guys for having me today. Any questions?
In any of your lessons, did you put in the diagram that we used at the South Pole that had the northern hemisphere versus the southern hemisphere on the CO2? Because that's a really interesting little juxtaposition.
No, I was not able to insert that in there, but we have a poster of that up at the observatory, and a lot of people ask questions about how, so what she's saying is during the southern hemisphere's summer, it's actually, they're getting less sunlight. So they have higher CO2 in the atmosphere. So when you look at the Keeling curve for Mauna Loa, it's actually inverted for the Southern Hemisphere observatories. And a lot of people ask questions about that, and kind of when they get that aha moment, they're like, oh, that makes complete sense now. But that should be something, definitely the older students would, high school students would definitely understand something like that. And I know it's a very different internship, but it's very unique in that I got to do less data and more public speaking.
Hi, I just had an opportunity to go to the laboratory in American Samoa a couple weeks ago, Matatula, and I was just wondering if you have any thoughts about, I don't know what your lesson plans look like, but it seems like that would be an interesting tool that would be useful for some of the classrooms there if they could be adapted. So I'm not sure if I can get your contact information.
Oh yeah, my email address is my name, alissa.phillips@noaa.gov, but I'll speak to you afterwards. And any of these plans, we would like to make them available because NOAA has a wealth of information online, especially the Global Monitoring Division, which has all of the observatories. So to make these available along with everything that they've made available in the past, a lot of stuff they have is kind of outdated, but now it would be nice to make those available for people who can't come to the observatory or who can't come to the Big Island. So.
Have you any consideration on working with the officer and the technician that are down at the South Pole Observatory? Because they have quite a bit of time on their hands, so you could do a joint project.
I don't know if I could stay there for 8 months and not have any communication with the world.
We have internet occasionally there, but yeah, you could certainly work with them just to bring information, because how many people ever get to go to Antarctica and everybody's like, wow, that's really cool.
Yeah, that would be an awesome opportunity if you know somebody. It's about who you know.
Well, even just while the other people are down there, you being here on the Big Island working with them and just getting information together.
Yeah, that would be perfect. Any other questions? Okay, thank you guys.
So Alyssa's mentors couldn't be here as she mentioned, but Don does have a few words that he's going to read for her.
Thanks, Alissa, for that great presentation. I have a statement from Aiden, since the two mentors couldn't be here. I'll quickly read it. Alissa has been a great contributor to the Mauna Loa Observatory over the last 2 months. Her youthful exuberance has had a positive effect on our small office, but her maturity is what impresses me the most and has allowed her to blend in well with our staff. She is a hard worker and highly motivated in and out of the office. Although her main function at MLO was to help us enhance our outreach capabilities, she spent her weekends getting scuba certified to add to her resume in the event that she chooses to pursue a career in marine biology. I wish we had an outreach position at MLO to offer her because she would be an asset to our observatory. Alissa has the knowledge and skills to succeed in whatever career path she chooses to pursue, and I for one hope it involves science education where she will have the ability to influence many future young minds in a positive way. It was a pleasure mentoring you this summer, and I wish you the best of luck in your future endeavors. Sincerely, Aiden Colton.
Our first talk this morning is by Charline Quenee from Biology and Marine Science, University of Miami. The title of the talk is Public Perception of Marine Issues and Education Strategies at the Waikiki Aquarium.
So good morning, my name is Charline Quenee, and I currently attend the University of Miami, where I'm majoring in marine science and biology. And this summer I had the fantastic opportunity to work in the education department at the Waikiki Aquarium. And today I'll be speaking about my internship project dealing with the public perception of marine issues and education strategies at the Waikiki Aquarium. So when I first arrived at the aquarium, the staff in the education department was working to come up with new exhibits and activities for the many renovations planned for the near future. One new exhibit was already set to open mid-July, and plans were in the works for some additions to the current galleries. With all of these impending changes, it was necessary to come up with new ideas and creative ways to display important information about marine issues that would both engage and educate the public. So when thinking of a project for myself, NOAA's mission statement of science, service, and stewardship was the first thing that came to mind. For the science to be appreciated, people need to feel that they are the stewards of our oceans. And along those lines, I kind of developed my main project, which would be to determine what kinds of programs would actually have the most impact on the visitors. So in order to plan for the new improvements, I needed to have a better understanding of what visitors thought of the aquarium. Perception is a powerful force, and I wanted to know what people really thought our primary function was. The next step would be to determine what marine issues visitors were or were not familiar with. People are typically more interested in learning about brand new things, so knowing where local knowledge stands would actually help plan exhibits that would draw people in. And once all the pieces were gathered, I would then be able to put them together to effectively plan for the new activities. So to compile the necessary data, I actually came up with a short survey, which I was able to post on the aquarium's Facebook page and pass out at local events. And to collect and analyze the survey, I used SurveyMonkey, which is a great and easy online tool that also keeps track of the responses and analyzes them for me. And in addition, I actually printed out a few paper copies, which I manually entered into the program so that I could reach a lot more people when we were at other events. So the survey was pretty short, consisting of 8 questions. Found that people don't really like taking surveys that take more than a couple minutes. And the first half of the questions were related to the actual data I was looking for. And the other half, I wanted to also have some demographic information so that I could do some further analysis. To make sure that the data was relevant, I actually used the first question to determine whether or not the respondents had visited Hawaii, and those who had not were actually eliminated from the survey. And with the different outlets used, I was able to collect over 100 responses in about 2 weeks, and the range of ages was from under 12 to approximately 75 years old. So I thought that was a pretty good representative sample. The first big question I asked dealt with the perception of the Waikiki Aquarium. What do people really think aquariums do these days? In the wake of certain recent documentaries, there has been a lot of public outrage and misunderstanding about the goals of many facilities. So in the survey, I gave respondents 6 choices: education, conservation, outreach, research, entertainment, and I have not visited the Waikiki Aquarium, which has been omitted for the purpose of this graph. I was happily surprised to find that most people see the Waikiki Aquarium's main purpose as education. The aquarium strives to educate all visitors, and its mission statement is to inspire and promote understanding, appreciation, and conservation of Pacific marine life. It's a lot easier to teach someone who is already interested in learning rather than in just being entertained. The next 2 questions I asked were focused on actual marine issues, and in order to determine what kind of emphasis needed to go into the planning of the new exhibits, I needed to know where the level of local knowledge stood. So I gave the respondents 5 choices encompassing the major issues we face today: marine pollution, ocean acidification, climate change, invasive species, and overfishing. When I closed the survey and looked at the responses, I was pretty interested to see that in Hawaii, people seem most informed on marine pollution and debris. Plastic debris is a huge concern here and gets a lot of attention. I, however, grew up on the East Coast, and I heard a lot more press on climate change and global warming, so it was surprising to me that the percentage for that category wasn't higher. To contrast the previous question, I then asked which issues the respondents had heard least about, and I gave them the same 5 choices. And this time the forerunner was ocean acidification. That one I pretty much expected, because people hear the words ocean acidification and their eyes tend to just kind of glaze over, and they think that it's a much too complicated issue for non-scientists to understand, but it's one that we should really all be concerned with. So the ocean scientist at the aquarium, Dr. Emily Smale, has been working to come up with simple yet impactful ways to showcase the marine issues in the new exhibits, and now knowing that ocean acidification is least understood, it will definitely receive the proper emphasis. So the final question I posed in the survey, and I'm sorry, I guess that didn't come out right, usually the words aren't tilted, but the final question I posed was to ask what methods the respondents found most effective to learn. And each respondent was asked to pick the top 3 out of 6 choices, with the possible answers being videos, websites and social media, hands-on activities, exhibits with written information, literature, and staff presentations of the exhibits. And not surprisingly, the hands-on activities received the most votes, because who doesn't really like to get involved? And the next highest poll was for staff presentations at the exhibits. Everyone I talked to at the aquarium really liked being able to interact with the staff and the volunteers while they were looking at the different exhibits because it made it a lot easier to understand what they were observing. And then after listening to the staff presentations, reading panels at the exhibits was the next highest. And again, I apologize, those were supposed to be lined up well. But all of those choices have in common that they're interactive and on-site. Visitors really like to see, touch, and experience at the same time that they're learning because it helps to better integrate and understand what is shown to them. I was actually a little bit surprised by the number of votes that the websites and social media received. In this day and age, it's a kind of uncommon thing to see a business or organization that doesn't have a Facebook page or a Twitter account. And as it turns out, they're really useful for getting information out to the general public, especially to a wide variety of people in a quick time frame. About half of the responses I got from my survey were from the aquarium's Facebook page. So as I mentioned earlier, the Waikiki Aquarium is currently undergoing multiple renovations, including the creation of an ocean science lab where visitors will be able to view displays on currents, tides, even tsunamis, and many of the ocean issues we're faced with today. So to educate local residents, I also took part in a couple outreach programs. Some of the more simple projects to spread awareness included local events like the North Shores Ocean Fest and the Honolulu Zoo's Conservation Festival. And there I was able to talk to people about local fauna and flora and pass out conservation brochures I made. And another really cool event that the aquarium hosts is beach cleanups. And we actually have a NOAA coastal restoration grant to organize massive removals of invasive algae, and with that we're partnered with the University of Hawaii at Manoa. So this summer, another thing I got to do was to help run a brand new teen interpreters program. We're training 14 teenagers from local high schools to be interpreters and run activities at the aquarium. And I thought this was a really great thing because I was lacking teens in the age representation for my survey. That was probably my lowest category. So it's really nice to have new ambassadors to reach out to local high schools about marine issues. While at the aquarium, I also had the opportunity to not only work on my own project, but on a variety of smaller projects. And I was in charge of the daily maintenance for the Critter Touch tank, which consisted of sea urchins and hermit crabs, and I had to go change those every 2 hours, so it was a nice break to get up and stretch and get my hands wet. And I also had the chance to revise an audio tour script. We opened some new exhibits about seahorses, so I revised the adult version of the script and actually completely wrote the child's version of the script. So I guess I'll have to go in and listen to it one of these days. And in addition, I reviewed the animal guide on the aquarium's website and wrote an article for the aquarium's magazine. So during my internship, the education department hosted 2 summer camp sessions for elementary school kids, and I got to participate in those as well. We educated the students about local marine fauna and taught them how to snorkel, and it was really awesome to see the kids' faces light up when they figured out why a certain organism was behaving a certain way. But my favorite thing was hearing them yell the state fish's 21-letter name through their snorkel while we were snorkeling. You would just sit there and you would just hear them all yelling, hoo, hoo, hoo. So that was really great. And a big part of working with children at the aquarium involves creating new educational activities. So like the previous presentation, there was a really neat education component to my internship. I was tasked with coming up with a new activity for a variety of age groups to learn about fish families. So I made a memory card game, which you can see on that far corner. Basically, if you've ever played the game of memory, you've got all the cards and you have to flip them over and make matches. So I made one for kids to learn about the body plans of various scientific families and kind of figure out, the distinct characteristics of each one. And it can be adapted a couple different ways to play with really young kids through adults. So hopefully that activity will soon be used for one of my favorite educational programs, the afternoons at the aquarium. Every Wednesday, we organized a kid-friendly activity or craft related to the ocean, and it was usually a really big hit, having 20 to 30 kids coming in at a time. And we would teach them about, the kids would come do the games and the crafting, and we would teach them about the ocean topic of the day, casually dropping some facts while they were making their Play-Doh seahorses or whatever it was that we were doing that day. And I really loved this activity because the kids would get so into it, it would really bring the parents into it as well and draw them to asking really good questions. So I was able to educate not just the kids, but also the parents. And if there's anything I learned is that the kids are the best way to get the adults to care. So overall, there's a lot of different ways to improve local ocean knowledge. And as the aquarium plans to renovate its galleries, frequently surveying the public is a fantastic way to make sure that the new exhibits are going to be useful and interesting to people. And as I continue my education, hopefully pursuing a graduate degree in some form of marine science, I'm definitely going to utilize the public as a general sounding board for major ideas. Because after all, what good is a project that no one's going to appreciate or understand? Thank you, and I hope you visit your local aquarium soon.
Be there in a second.
Thank you. Well, I might be curious about the responders. Who are the respondents of this questionnaire survey?
So when I was doing it, I started out, I made the survey and I went around and I actually had the survey on my phone because a lot of the events that we were doing didn't have any kind of Wi-Fi capabilities and we didn't have a tablet available. So I had the survey on my phone and I was going around, and as people would come around the booths, I would ask them if they would be willing to participate in a survey. And I tried to remain as, steady as possible, trying to ask every single person that came there, and whether they said yes or no, I would, try to ask. I wasn't pushing it for people who didn't want to do it, but that's when I got the idea of printing out the papers. It was a lot easier. I didn't want to kill trees, but the papers just made it a lot easier for people to just circle everything real quick and then just hand it back to me.
I mean, do you know their background, their academic background?
I don't have academic backgrounds. The questions I asked in demographics were whether or not they were Hawaiian residents that I wanted to know, and I had about 3/4 of them were Hawaiian residents, and the other ones were visitors. And then I asked if they had visited the Waiheke Aquarium, yes or no, and their age group, and if they had been to Hawaii were the other questions I asked. I didn't ask male, female, educational background. I really wanted to keep it short and sweet because people, if I'm out at events doing it in the field, it's not a lot of time to be able to take long surveys.
Well, as it is a perception study, so it might be interesting if we know that what certain group of people responses are different from other group of people. I mean, higher education, people having higher education, how did they respond to your answers, and people having relatively lower education, what did they say? Number one. Number two is that, again, different economic backgrounds. I mean, rich people, how did they react to your questions, and others, how did they respond? I mean, this might be interesting if you can add in future. I mean, the perception of different group of people to certain things.
Yeah, I think if I took this further, that would definitely be a really interesting
Thanks.
component. Thank you.
Any other?
Not, who's going to speak?
Did you cover your future long-term, short-term?
Well, I'm going into my senior year at the University of Miami, and at first I actually wanted to just go into the Peace Corps right after, and then I figured out that was because I didn't know what I wanted to do in grad school, and now I have a much better idea. I really want to work with marine protected areas, and kind of not just the biology of it, but also the anthropological impact of it. I really like studying coastal culture, so hopefully I can find a program for that and go to grad school in the next year or so. That's it.
Who's going to be speaking?
Hello, I'm Emily Smale. I work in the Education Department at the Waikiki Aquarium, and we've been very happy to have intern extraordinaire Charline with us this summer. She's helped us develop a lot of educational materials that we're going to continue to use, everywhere from small children to adult materials. And her information and her survey is going to be really helpful for me in designing our programs and exhibits in the future.
Okay, thank you. We should move right along to our second talk, which is one by Jacob Tepper, Marine Biology, OSU. And the title is A Comparison of Macrobenthic Organisms in Shallow Water and Mesophotic Coral Reef Ecosystems of the NWHI.
All right, hi, I'm Jacob Tepper. I'm from Oregon State University, studying marine biology. So the goal of this project was to quantify the abundance and distribution of macrobenthic organisms and mesophotic reefs in the northwestern Hawaiian Islands. And I worked in the Papahanaumokuakea Marine National Monument Division with Dr. Daniel Wagner and Dr. Randall Kosapi, who can't be here right now, but who were great mentors. So Papahanaumokuakea Marine National Monument is the largest marine protected area in the United States. It surrounds the northwestern Hawaiian Islands, and it's also one of the largest coral reefs in the United States. So a little bit about coral reefs. They're some of the most diverse ecosystems in the world. Unfortunately, however, they're also extremely threatened by anthropogenic factors such as overfishing, runoff, pollution, and climate change, such as ocean acidification and other stuff that we've heard about. So as reefs decline worldwide, it's increasingly important to document the biodiversity of pristine habitats such as the northwestern Hawaiian Islands. So this picture shows that scuba surveys worldwide have collected data on reefs down to about 25 meters, and submersibles have collected data from 200 meters down to even deeper than that. But the depth between the zone, from around 25 to 200 meters, is largely undersurveyed. And it's known that photosynthetic corals are found down to at least 165 meters. So this intermediate depth zone is known as mesophotic coral reef ecosystems, or MCEs, and they have light-dependent corals. So MCEs, they're deep reef communities found from 30 to 200 meters down. They have zooxanthellae coral, or photosynthetic coral, that have symbiotic algae to photosynthesize. There's also azooxanthellae coral, or non-photosynthetic coral, pictured here, like black corals, among other things. A large composition of this ecosystem is macroalgae, and then there's also many sponges. It's been suggested that these deep reefs may serve as an important refuge for shallow water reefs to replenish populations of fish and even corals. And MCs are an important component of the whole coral reef ecosystem, and as such, they should be considered in any ecosystem-based management plan. So since 2009, expeditions have been conducted annually to the northwestern Hawaiian Islands to conduct surveys on these mesophotic reefs. And this project aims to help protect the monument's ecosystems by using this data to further our knowledge of these mesophotic ecosystems. This project interested me, particularly because it focuses on biodiversity of coral reefs, and I'm particularly interested in coral reef ecology. I got to work with a lot of large data sets of ecological data and did a lot of data analysis, which I previously hadn't done. So we're looking mainly at the benthic composition, which is basically the bottom of the reef, whatever is found there, to learn about biodiversity. And the northwestern Hawaiian Islands are unique in that they are a pristine ecosystem due to a lack of human influences. There's been no large human population that has lived on any of these islands for as long as we know. And data from the northwestern Hawaiian Islands also provides a great baseline of what a natural ecosystem undisturbed should look like and what other NPAs can compare themselves to and strive for. So my first hypothesis was that there would be a difference in benthic composition among the different islands in just the mesophotic reefs. And then my second hypothesis being that there's a difference in benthic composition between the mesophotic reefs and the shallow reefs. So on to the methods. Dive surveys were conducted at mesophotic depths of about 60 meters and also at shallow depths of less than 30 meters. Using a 25-meter belt transect, photos were taken with a standard 0.5 meters quadrat, about 25 photos per transect. Any organisms that weren't identifiable in the field were collected for later identification. So here's a picture of one of the divers with a photo quadrat right here, taking a picture. And so what I did was mostly the data analysis of these pictures that were taken, and the benthic cover was determined using this software called Coral Point Count with Excel extension. It basically places 100 random points over the picture, and I identify what each point is, what organism it is, down to the lowest possible taxonomic level. And I did about 20 images per location for both mesophotic reefs and shallow water reefs. And the locations were Nihoa, Lisiansky, French Frigate Shoals, and Pearl and Hermes Atoll. So on to some of the results. So at the right here, we have the legend for these pie charts. And basically we found that macrobenthic composition does vary among the islands of the mesophotic reefs. So this is just the mesophotic reefs right now that we're looking at. And if we look at in blue is coral cover, percent coral cover, starting from the lowest latitude island, Nihoa, moving north. We see there's around 15% coral cover here. There's only 3% in French Frigate Shoals, and around none in Lisiansky and Pearl and Hermes. So with increasing latitude, we see decreasing coral cover. In yellow is sand, and it's about the same throughout. There's a bit more in Nihoa. And one interesting thing we found in light green is green macroalgae. There seem to be more in these northern islands, mainly composed of a microdictyon species. So that was interesting. And most of the rest of the composition varied, but yeah. So now we're just looking at by island, the shallow reefs versus the mesophotic reefs, starting with Nihoa. So the top one is the shallow reef and the bottom is the mesophotic reef. Interestingly here, in blue once again is coral cover. We see there's actually more coral cover in the mesophotic reef here at Nihoa, which is interesting. We'd expect the opposite, but it wasn't the case for Nihoa. The sand composition in yellow is about the same. Dark green is turf algae, and there seems to be more turf algae in the shallow reefs versus the mesophotic reefs. So here's French Frigate Shoals, and this is exactly what we would expect. In the shallow reef, in blue is coral cover, purple is coralline algae, dark green is turf algae, and so it's large percent coral cover, a lot of coralline algae, and some turf algae. Much more coral cover in the shallow reef versus the mesophotic reef. That's exactly what we'd expect. And there's more sand in the deeper reefs, and all the rest of these covers are different types of brown macroalgae, red macroalgae, orange is cyanobacteria, so there's a bit more macroalgae. So now Lisiansky, once again, we see a lot more coral cover in the shallow reef versus the mesophotic reef. There's also in light green, much more green macroalgae in the mesophotic reefs. That seems to be a trend we're seeing, and there's more sand. So Pearl and Hermes is the last island we did, and this one was interesting in that there's almost no coral cover in either the shallow or the mesophotic reefs, and not really sure why. It might just be sampling sites where data was collected, but there's a lot. This dark green is turf algae. There's a lot of turf algae in the shallow reef, and much more macroalgae and coralline algae in the mesophotic reef. So here is the total macrobenthic composition of all the shallow data versus all the mesophotic data combined from each island. So on the left is the shallow reefs, and we see, I think it's around 20-something% of coral cover in blue, whereas there's only around 5% in the mesophotic reefs, so there's more coral cover in the shallow reefs as we'd expect. There's much more sand in the deeper reefs, and much more macroalgae in these colors here. Coralline algae is about the same, and same with turf algae. So this is that same data in a bar graph. And just looking one at a time, I'm just going to go over a couple of these. Coral cover, like I said, there's around 23%. Blue is shallow reefs, and red is mesophotic reefs. It's only around 5 in the deeper reefs. Green algae, or green macroalgae, is much higher in the mesophotic reefs. There's more sand in the mesophotic reefs. Coralline algae is about the same, and there seems to be more turf algae in the shallow reefs. Now you can see that error bars are really high, so this is still good data, but one of the next steps is to do statistical tests to see if this is actually significant. The error bars suggest it's not, but statistical tests are still to be determined. I'm actually going to be coming back here after the talk in Maryland for 3 more weeks to hopefully write this up as a scientific paper. I have 1 more year left at Oregon State University, plan to graduate, and then either work for NOAA or maybe go to graduate school. So in summary, we found that the macrobenthic composition does vary among the different islands. Macrobenthic composition also varies between the mesophotic reefs and the shallow water reefs. And it's likely that temperature plays a large role in determining the distribution and abundance of corals. So as we saw with increasing latitude, we saw less coral cover. With increasing latitude, there's lower water temperatures, and also with increasing depth or lower water temperatures, we see less coral cover. So that's likely that temperature is a large factor in determining their distribution. And with that, I'd like to thank Dr. Daniel Wagner and Dr. Wendy Kosaki for being great mentors and helping me with the project and just allowing me this great opportunity. Dr. Heather Spalding for helping with algae identification, which can be very difficult, especially just from pictures. And Jason Leonard and the rest of the crew who took me out diving just for fun. Thank you.
So, are there any questions?
Same genus, but not same species. There are a few species that are found fairly deep, but it's mostly the same genus. Yeah.
How did they choose what part of the islands to survey?
That's a good question. I know for the mesophotic reefs, they specifically tried to survey areas that were not sandy bottoms as to collect data on diversity, because most sandy bottoms were just sand, so it was usually some benthic composition. But I don't know how they chose the exact sites.
Any more questions?
I guess this is theoretical, but if the same research and same process was done for the actual islands that make up the state of Hawaii, do you believe that it would be the same findings would come out, or no, because it's too much impact by humans?
Yeah, so if it was done for the main Hawaiian Islands, because the reefs here, or most of them, are highly impacted by humans, a lot of the coral cover, I'm sure if you compared the shallow reefs of the northwestern Hawaiian Islands to the shallow reefs here, you'd see much more coral cover in the northwestern Hawaiian Islands. Yeah, just because of human impacts.
Even though it was at depths of, you said, up to...
So the mesophotic reefs might actually not be different. That would be interesting, yeah.
That might be...
Yeah, that might not be, that's one thing they say it might be a refuge because there's less impacts by humans. Even if the shallow reefs here on the main islands are affected a lot, the mesophotic reefs might not be. So that's, yeah.
Are there any mentors in the audience?
Was Daniel able to make it today?
No.
We'll try to get a statement later from him.
Yeah, no, it's he's out diving today.
I'm sure it was a nice statement.
Cool. Okay, our third talk this morning is by Lyndsey King, and she comes from Marine Science, Coastal Carolina University. And the title of the talk is Body Lengths at Median Reproductive Maturity for 2 Commercially Valuable Reef Fish Species.
Thank you, Ed. As Ed mentioned, my name is Lyndsey King. I am from Pennsylvania, but I go to school in South Carolina at Coastal Carolina University. I study marine science and I have an environmental science minor. Since I've been here, I've been working with the Life History program under Bob Humphreys and Ed DiMartini. They've been great and they've helped me a lot during my study on body lengths at median reproductive maturity for 2 commercially valuable reef fish species. So before I get started, I'm just going to give you a brief outline of what I'll talk about. I wanted to start with NOAA's goal and how my project fits into that, as well as give you an introduction to my project, and then give you a background information on a few of the fish that I studied, as well as my methodology and my results, and then some future steps for both myself and the project, and then of course a summary and my acknowledgements. So I wanted to start with NOAA's goals to show the greater importance of what my project is and how it fits into NOAA's goal. So my project falls under NOAA's goal of healthy oceans, which focuses on resource fish to help eliminate overfishing, as well as rebuild any fish stocks that may have already been overfished. And in the long term, this goal works to ensure the stability of the future for both recreational and commercial use of these fish stocks. As well as fitting into NOAA's goal, my project falls under PIF's goal as well, as it provides guidelines for both management and conservation plans for these two commercially valuable reef fish species. So keeping NOAA's goal in mind, my project focuses on the median length at reproductive maturity, or the L50, of two commercially valuable reef fish species from American Samoa. And L50s can be used to develop guidelines for local agency and conservation plans, so like setting size limit regulations, as well as adding to the understanding of the overall life history of resource species. The Myropristis burnti, or Mempachi, is the first of two holocentrid species that I studied here. They can be found in the Indo-Pacific and Eastern Pacific, and they're nocturnal, so they feed at night on zooplankton well above the bottom. And then Sargocentrontieri, or the Tahitian squirrelfish, is the second fish holocentrid species that I studied. They are also found in the Indo-Pacific and are nocturnal, but unlike Mempachi, they feed on benthic crustaceans, so they are found mostly near the bottom. So by now you're probably wondering why, if I spent my time in Hawaii, did I choose to study fish in American Samoa, and why did I focus on holocentrids instead of any other species? So as of right now, there are absolutely no size limit regulations for any reef fish species in American Samoa, even though their reef fish industry is so important to them. And on top of this, there is limited life history data available worldwide for holocentrids, and reproductive information is absolutely lacking for the two species that I studied. So with this limited knowledge and the fact that the Department of Marine and Wildlife Resources in American Samoa is actively searching for data to help them set regulations for these reef fishes, these two factors really shaped the purpose of this project. So before I started working, samples were taken from markets in American Samoa, and these reef fish were processed, and gonads and otoliths were extracted, and then gonads were sent to an external contractor and prepared as histology slides. And then my work started with these histology slides. So I examined 313 specimens microscopically and scored them both for sexual identity, so whether they're males or females, as well as their maturation stage, focusing specifically on if they're mature or immature. And to give you a little taste of what I looked at, this is a typical female and male, and they're both mature. You can see females have this characteristic pink stain, and that marks maturation in them. And as their cells mature, they actually grow larger. So their purple cells are immature cells, and then as they mature, they turn into these pink cells. And males are actually completely opposite of this. So as their cells mature, they will grow smaller in size. And you can see the mature tailed sperm is the smallest cell seen in this photograph. And after I went through these 313 specimens, and they don't all look like this, they're not all this easy, but after I went through those and collected all the data, I was able to insert the data into the PC program SAS to separate specimens into 1 centimeter fork length classes, and then determine the percent maturity in each class. And then with this information, I was able to fit a logistic curve showing the percent mature versus the length classes to determine their length at median reproductive maturity. So these are the fits that I made for Myropristis burnti. You can see the percent mature versus a median fork length, and female data is represented with pink dots, while male data is represented with blue. And you can see females, a female L50 was around 17 centimeters, while males was around 18 centimeters. And there is a 1 centimeter gap between their maturation sizes. And this gap is also present for Sargocentrontieri, so males are maturing at 1 centimeter larger than females. And you can see female L50 is approximately 15 centimeters, while males is around 16 centimeters. And the female L50 is an approximation because we did not have enough smaller fish to include that number in our data set. So this is a projection outside of our data range. Along with finding the L50 for these species, I also found preliminary evidence of sex change in these fish. If you remember, this looks like a typical mature male, but if you look a little bit closer, there is an early alpha stage atretic oocyte, which is simply a female cell that still has yolk present in it, and it's being absorbed back into the gonad tissue. And nearby, there's also a beta stage atretic oocyte, which is older than the first one, so there's no yolk present, but it is still a female oocyte. And throughout this specimen, as well as several other males that I examined, I found delta stage atretic follicles, which aren't necessarily female oocytes, but very well could be. So with this information, as well as the fact that males are maturing at a larger size than females, which is uncommon for fish that don't change sex, it's very possible that this may be evidence for sex change in these fish. And if this is true, this would be the first evidence of sex change in any holocentrid or bursiform fish. In the future, additional specimens are still definitely needed to improve our estimates of L50, as well as explore this possibility of sex change in these fishes. As you can see, this graph shows the frequency of landings versus either the fork length of fish or the months they were caught. You can see there are several months that have no fish or very few fish that were caught, as well as a high abundance of males at larger fork lengths and very few smaller fish. So if we can continue to collect more specimens and fill in these holes, we'll be able to definitely improve our L50 estimates, as well as have more specimens to explore the possibility of sex change. Along with this additional work, PIFS is planning on doing an age at median maturity estimate using otoliths from the fish that I've studied already. So with that additional information and the extra specimens that will be collected, I will start working on my senior honors thesis for school, as well as a publication of the results with Ed. And then, so in summary, I would just like to say that using gonad histology this summer, I was able to determine that the length at median reproductive for Myropristis burntide was 17 centimeters for females and 18 centimeters for males, while Sargocentron tieri was about 15 centimeters for females and 16 centimeters for males, both of which displayed a 1 centimeter difference between male and female maturation. And this data can be used to suggest guidelines for setting minimum size restrictions in American Samoa, which will help promote a sustainable fishery there, as well as ensure a stable future for the fishes there. And with the addition of more specimens and the age at median reproductive maturity studies, I will be able to continue this study and write up my findings for both my senior honors thesis as well as a publication. And I would like to thank Ed for being such a fantastic mentor. He's made my time here amazing. And I only see Jeppe in the audience, so I would like to thank Jeppe for all of his help and his encouragement in this beautiful day today. So thank you all.
Sure there must be. Who's got the mic? Just speak loudly.
A couple of questions. So you can't tell them apart in the water, the males and females?
No, they look the same.
Okay.
So the picture that I showed, they all look like that.
Okay. And also, I know that there's some kind of volunteer fishermen, like with Dar and stuff, they were having fishermen kind of on their own send in gonads that they had collected when they were fishing. Do you know if there's anything like that in American Samoa to help get samples?
I'm not sure if that's right. That's a good question. I know the samples that I studied were from marketplaces, so they were taken from markets. But I don't see as though why that wouldn't work if they take the correct data. So they would have to take fork lengths and weights and everything like that. So.
Other questions? Was it both species that might be changing sex, or just one species?
Yep. The picture that I showed was in Sargos entrantieri. That's the only evidence that I found that had actual oocytes in it. But both species had the delta stage atretic follicles, and although those aren't necessary, they could be any atretic cell. But in comparison with female atresia and the presence of them in only some males, it's suggested that it could be female oocytes.
I can shout, I think.
Yeah, but then the people online can't hear you.
Okay, they can hear me, trust me, I'm loud. So basically following on that question, is there a specific size in the range of fish you looked at? Is there a specific size where you see those oocytes?
Through the fish that I studied, most of the ones that I found were in mature males, which was surprising because you would expect it to be in the immature males who were changing sex. But I think we would need more specimens to figure that out because we didn't have very many small fish.
Very cool.
How are we doing on time? More questions?
Well, I'll say a few words. Bob Humphreys is not here, unfortunately, because he's still coming back from the cruise. But it was truly a remarkable experience for me this summer because Lyndsey, as you can tell, is one very qualified and enthusiastic person with great aptitude for this sort of work. And I can't thank her enough. And it's especially important because recently our program's been tasked with rather challenging responsibilities of looking at these types of projects for multiple species and multiple jurisdictions. American Samoa is just one. It's also Guam and the CNMI. And in fact, Bob Humphreys has a milestone this year trying to piece together as much of this multi-species information as possible to be able to provide to these, for availability of this type of information to local management agencies because of the pressing need for it. And all I can say is she's contributed immeasurably to us getting this type of information out. These are two important species of American Samoa. We have on our plate 6 total species for this calendar or for this fiscal year, and we're well on our way, much due to her diligence and excellent performance. So I can't thank you enough. Okay, are we ready for Thomas Vaughan, East Carolina University Atmospheric Science. Title is Seasonal Rainfall Variability and Forecasts for the Hawaiian Islands.
I am Thomas Vaughan. I'm a student at East Carolina University, and I'm an applied atmospheric science major. And I did my project on seasonal rainfall variability and forecasts for the Hawaiian Islands at the Pacific INSO Applications Climate Center, which is actually on the campus of the University of Hawaii at NOAA. And it falls under the NOAA mission goal of climate adaptation and mitigation. And my NOAA mentor was Lieutenant J.G. Carl Noblet, and my co-mentor was Dr. Rashid Chowdhury, the principal research scientist at PX Center. So a little bit about the PX Center. The PX Center provides information products to the U.S. affiliated Pacific Islands as it relates to the El Nino Southern Oscillation, or ENSO, climate pattern, and also its historical impacts and long-term seasonal forecast information. And so the objectives of my project were to develop an operational rainfall forecast specifically for the Hawaiian Islands, based on the seasonal timescales, and also to provide the PX Center with important information regarding how ENSO can affect rainfall in Hawaii. So my hypothesis was that seasonal rainfall in Hawaii is affected by ENSO, and this information can be used to create a forecast through the use of composite maps, correlation maps, and canonical correlation analysis, which I'll get more into in a second. But a little background about El Nino. So during normal years, we generally have cooler sea surface temperatures in the eastern Pacific and warmer sea surface temperatures in the western Pacific. And during El Nino, we kind of see the warmer sea surface temperatures migrate east into the area that's known as the Nino 3.4, and that's from 120 west to 170 west and 5 degrees north and south of the equator. And that's generally the best area to kind of determine if an El Nino is present. And then we also have the opposite of that, which is La Nina, which is cooler than normal sea surface temperatures in this area. And so what these maps are, the one on the left is sea surface temperature anomalies for the 5 strongest El Nino years. And so this is, we see warming in along the equator in this area, which would indicate that an El Nino is present. And there's also an atmospheric component to El Nino as well, and there's sea level also changes due to the trade winds weakening. But for this, we mainly looked at sea surface temperatures. El Nino affects rainfall patterns around the world, as you can see with this map. So this is, even though it occurs in the tropical Pacific, it's something that has impacts all around the world, especially for this area, it can cause drier rainfall. So I created composite maps and correlation maps using NOAA's Earth System Research Laboratory website, and then I conducted canonical correlation analysis using IRI's climate predictability tool software. And for my analysis, I assumed that El Nino developed in the July, August, September season, which it doesn't always develop in that season, but the majority of the time it does. So that was assumed here. So the first thing I did is I took rainfall data from 4 stations in Hawaii, Honolulu, Hilo, Kahului, and Lihue, and took the seasonal average for January, February, and March, and compared that, and that was over the past 50 years, so from 1951 to 2012, and then I compared that to the seasonal average specifically during strong El Nino years. And what we see is that during the January, February, March season, the rainfall across the board for all stations was significantly lower. And then I did the same thing for moderate El Nino years, and it was still lower, but it didn't show up as well, which is to be expected if the El Ninos aren't as strong. So then I made sea surface temperature composite maps, and these maps show the sea surface temperature anomalies during the January, February, March season after the onset of El Nino for the 5 lowest rainfall years for each station. So the years for these maps are all different. It's just for the same season during the lowest rainfall years for that particular station. And the interesting thing we see here is that for January, February, March, all of these show an El Nino pattern. So that would tell us that during El Nino years, we can expect that Hawaii would receive the lowest rainfall amounts during January, February, March. And then for the highest rainfall years, I did the same thing, and we see that most of them show a La Nina pattern, which would again suggest that during La Nina years, January, February, March is the season when Hawaii would typically see the highest rainfall. And then I created correlation maps. So these relate the sea surface temperatures to the rainfall data. And we would expect, based on the composite maps that were created, we would expect to see negative correlation. So when sea surface temperatures were high, rainfall was low, and when sea surface temperatures were low, rainfall was high. And we do actually see negative correlation for most of the stations. Kahului, it doesn't show up very well, but we do see it for the other 3 stations. A couple things to note. For Hilo, the La Nina signal for the highest rainfall years actually was stronger in OND, October, November, December. So that maybe could suggest that Hilo could expect their highest rainfall during La Ninas a little bit before the rest of the Hawaiian Islands, but that would require more stations to confirm that. And also there was a discrepancy with Lihue. The lowest rainfall seasons for October, November, December actually show a La Nina pattern, but it's negative correlation. But we would expect to see a positive correlation with La Nina if the sea surface temperatures were lower. We would expect the positive correlation there, and we see negative. So that doesn't really, that's a point that would require more research. And I did this with the other seasons as well. I made a lot of these maps for the whole year for all of these stations, and the other maps did not really indicate a very strong relationship. So basically the take-home message from this is that January, February, March is the best season for making forecasts based on INSO for Hawaii. And so then I performed canonical correlation analysis, and I did hindcast analysis, and I did that with data from both 1951 to 2011 and data from 1982 to 2011 using a 0 season lead time with the CPT software. And the forecasts for AMJ and OND rainfall were not very promising, as you can see at the bottom charts. But the forecasts for July, August, September, and January, February, March were much more skillful, and particularly for Hilo, Kahului, and Honolulu. And it also showed that the most recent data produced better forecasts, which makes sense in a changing climate, so that was kind of to be expected. And then finally I did a forecast verification. So the table on the left is the forecast probabilities that were generated from the CCA. And then I took that and made it into a tercile forecast and then verified it with what actually happened. So this shows that the forecast that was generated using the canonical correlation analysis was pretty accurate because it was only, we can see it was only off there 3 times, which is very good for a seasonal rainfall forecast. So that was very promising. So just sum everything up, Hawaii can typically expect the driest conditions with El Nino in January, February, and March. Honolulu, Kailui, and Lihue can expect highest rainfall with La Nina in January, February, March, and Hilo may see it a little bit earlier. And the canonical correlation analysis showed that sea surface temperatures are really better for forecasting rainfall for JS and JFM, and particularly using more recent data. So the next steps of this project, it could be done again using zonal wind data, and that actually has already kind of been started. I've made the composite maps and the correlation maps for that, so basically all you have to do is collect the wind data and run the CCA. And then it can also be used for additional stations in Hawaii and see how that compares. And personal goals for me, I plan to pursue a master's in meteorology or atmospheric science after I graduate in May, and possibly continue INSO and U.S. affiliated Pacific Island related studies in graduate school. We'll see how that goes. And last but not least, I'd like to thank my mentor, Lieutenant J.G. Noblet, Dr. Rashid Chaudhry, and Alejandro Luder, the PIAC grad research assistant, and then PIAC's partners, the National Weather Service, UH, and the University of Hawaii. And at this time, I'll take any questions you may have.
complete ignorance. I'm a fisheries biologist, but I'm pretty interested in oceanography and climate also. And according to the Climate Prediction Center, there's a high degree of certainty of a ENSO event coming up this year. So we should, based on your analysis, we should be expecting a relatively dry beginning of 2015.
That is something that we've been monitoring at the PX Center. It looks like the El Nino, I think it's currently fizzling out a little bit, so it's still, we're under an El Nino watch, I think was the latest update that we had. But that's true, if there were to be an El Nino developed, particularly a strong El Nino, then the main Hawaiian Islands could expect a very dry January, February, March season.
And my second question is, I noticed that the Climate Prediction Center is also incorporating subsurface temperatures into their models too. And would you consider doing something like that for your research in the future?
Yeah, I would not see a reason why that could not be done. It would be interesting to see how it compares to the surface temperatures. So I don't know. That's something that we could look into.
Thank you.
I'd be curious what put you onto the interest in wind, whether or not you knew that there's a possible real direct relation to one of our fishery limit monitoring and knowing something in advance about wind, and whether you have any initial idea whether it would be like rain or the opposite. In other words, the wind and rain go together or the opposite.
Right. So the reason that I suggested it could be done with wind is because wind is also a part of El Nino. So during El Nino, the trade winds weaken and can actually reverse. So that's why I said it could also be done using zonal wind information, because we do see changes in wind when El Nino happens. And those typically go with the sea surface temperatures, not always. Sometimes there's a lag there, so it can be kind of tricky, but that's why I said we could do it.
So that meant a dry year would also be less windy?
Well, not necessarily, because you would have the east-west trade winds would weaken, but they can also reverse if it's a really strong El Nino. So I don't really know if that would make a big difference.
Any other specific questions? If not, is Lieutenant Noblet or anything?
Thank you. Lieutenant Gigi Noblet with NOAA. I want to take this moment to put in a little plug for those of you who are graduating. If you like to be out to sea on ships and boats, and then you want to do research shoreside, I'm on a 2-3 rotation, 2 years at sea, 3 years at land, and I'm loving it. So if you all are interested in it, come talk to me during lunch, and I'd be happy to tell you more about NOAA. As for Thomas, great job, thank you. And I'll keep this short and sweet since we're going to head to lunch right now. Thomas was in a unique position coming to his summer internship at the PX Center. Upon arriving at the PX Center, he had only limited knowledge of conical correlation analysis, and it had been months since he studied El Nino. He was able to adapt and learn quickly, and he made great progress managing his project work within a diverse co-mentor environment. Under Rashid Chowdhury, Thomas learned forecasts on seasonal timescale, CCA, and how to use climate predictability tool software. Through me, Thomas looked at understanding monthly conference calls, become acquainted with the PX Center's activities related to climate forecasts, outreach, and products. With that said, thank you, Thomas, for your dedication, hard work, and contributing to our goals and endeavors of the PX Center.
Work here at the Pacific Islands Fisheries Science Center in Protected Species, and I'm going to be moderating the next session of the symposium. So, welcome back. And first up, we have Jeppe Stig-Nielsen from the University of Wisconsin-Madison, studying economics. He's a PYSO intern this summer with Coulter Kalberg and Don Kotowitz. He's going to be talking today about supply chain risk management of wholesale fish buying in response to a fishery closure.
Eat cheese or die.
Is that good right there? Yeah. All right, so my project is supply chain risk management of wholesale fish farming in response to changing management in the longline fishery. So I want to start out by giving you guys a little background on the fishery itself. The big eye is handled by a total allowable catch, and that limit is set at 3,763 metric tons, and that is for the Western Central Pacific Ocean, which is where the majority of their catch comes from. Back in 2009 and 2010, they reached that quota, which led to a closure, the latter of the two being much more severe as it lasted for 40 days, and only in 2009 it was only a 4-day period. Currently there are 135 longline fishing vessels operating, and that statistic is as of January 10th, 2014. Wholesalers and retailers rely heavily on the market here locally in Hawaii. So to give you guys a little more information on what I've been doing, I started out by reviewing previous literature on other fisheries and previous works that had been done on the behavior following the closure immediately, and that was done by one of my mentors, Don Kodowitz, whom is not here today, but she examined the social science aspect of many of these things. And then my other mentor, Coulter Kahlberg, he's on the economic side of things and has provided me with a lot of helpful data. So I've been taking this quantitative and qualitative data from interviewing buyers and retailers and compiling that with statistics I have, and hopefully I will be able to draw some conclusions. So, and my paper that I'm working on is examining changes in profitability, imports and exports, and behavior of buyers. So here I have just a small diagram of the supply chains, and the difference is one of them is with imports and one is not. So on the far left here we have longline fishing vessels that come in locally to the auction here over in Pier 38 in Honolulu. And then you have the buyers there that bid on this big eye, and there's also other catch there, but the majority of the landings is big eye. And then these buyers, they then distribute to wholesalers and retailers amongst Hawaii in general, because most of the landed fish here stays in Hawaii. And then it ends up in consumers' hands like ourselves. The imports over here, however, they come in to importers. Some of those are auction buyers, and that's what I'm examining, but it's not all of them. There's a lot of buyers that will only purchase fish locally. And these importers then, again, distribute to other wholesalers and retailers, not necessarily the same ones, because some people are adamant about selling local fish only. And then it ends up in other consumers' hands, which is a different market segment of consumers, essentially, because here in Hawaii, people prefer local big eye. So here I have a chart for you guys to show you the imports and exports in recent years. And as you can see, about the end of 2010, which is when there was the most recent closure, imports began to overtake exports for the most part, and it's been gradually increasing over time. The next chart I have here is the value of imports per pound versus the value of exports per pound. And as you can see, the export per pound is typically much higher and gradually growing, but down here in 2012, the gap is kind of diminished. So here I just want to show you anything in the market that is marketed as ahi. It includes big eye and yellowfin. However, big eye is the focus of, or the target of the fishery, and as you can see, they land a lot more big eye than they do yellowfin. Big eye is also much more valuable than yellowfin. Not necessarily much more, but on average it always is higher quality and it costs more per pound. However, the two are substitutes, so the prices per pound correlate. So I began by interviewing fishermen within the fishery, and it was a little bit tough to get information from them about their strategy since the closure. You know, really, the main thing I want to point out here is the relationships between the buyers and fishermen. One time I was interviewing a captain, and a buyer comes over to him, gives him a big hug, tells him he pumped up the price for him, and relationships like those really stand out because they can kind of control the price in the market at the auction. But all in all, it's not easy to conclude their strategy because they are the most invested in the market, and thus they don't have much room to move around in the long term or short term. Buyers, however, they have very interesting behavior because, as I mentioned earlier, you have your local buyers only, and then you have buyers who purchase locally and import. The local buyers, they aren't changing their strategy since the closure. They tell me that they only feel the impact of the closure if it occurs, which it hasn't since 2010, thankfully. But with regards to prices, they say it's a day-to-day thing. Not surprisingly, it fluctuates. And they are relying on the fishermen to bring back good fish every day, which is not necessarily true or not reliable because some days you'll have 100,000 pounds at the auction and then the next day there'll be 0 pounds of landing. So that is why some of these buyers are importing and increasing their imports because populations have grown, demand is increasing for the big eye. And so these importers, I believe it's the only way to, as I have a quote there, importing is the only way to stay consistent with your supply and prices. And that it's very true because when you're importing, you get a set quantity, a set quality, and a set price. Whereas here at the auction, you're bidding on these prices, so you don't know if it's going to be high prices that day, if there were low landings, all that stuff. It's unreliable in many ways. And another quote there, we would prefer the locally caught fish, but in the end, we still have a business to run and can't depend on the local market. And that's essentially because the fish that comes in here is higher quality. However, it's unreliable, as I've mentioned, with the way the auction is run in some manners. Retailers' behavior resembles the buyer's behavior very much so. So prices have been observed at, for poke, $16.99 per pound versus $11.99, or that's for local, versus $11.99 per pound for imported or previously frozen poke. And I mean, that $5 price gap is rather significant, and that's due to the local supply being limited under this catch system and how much is coming in per day. However, you still do have your retailers that are selling local, big eye only, and these retailers are, they say it's benefiting the business. They aren't changing their strategy because they have consumers that will come to them specifically for that local catch. It seems the bigger stores are importing, and the majority of poke that they carry is imported fish. And they say, as you can see here, you can't always get it local and fresh. The demand is so high that you have to import in order to compete. And they don't want to push that or transfer the price onto their consumers. Here in Hawaii, as I mentioned earlier, the demand for local big eye is much higher than back on the mainland where people don't notice that difference. There's been studies done on that. So basically, to summarize what I've already told you, there was previous research done back in 2010 following the auction to see how buyers behaved and managed in the market and what strategy they took. I've been examining that to see if that's continued or not and how it's changed if it has. We have noticed a clear trend in imports increasing since the closure while exports are decreasing. And that's largely due to the fact that we believe this local big eye is staying here in the Hawaiian market. There hasn't been an apparent change in the market behavior of local buyers or retailers, and that is also because, in a sense, they're taking the strategy to not import, essentially. And yeah, the people who are importing are not attributing this to the closure itself, solely because their demand is higher and they need something that they can rely on. So the next steps that I have basically left to do, I'm going to conduct a few more interviews later this week down at the auction, and then also with a couple of retailers, hoping to set up a couple interviews for that. And I'm basically going to compile all the notes I have from my interviews and also the data I showed you earlier with imports and exports charts. And I'm hoping to draw some conclusions on that and how it's affecting the market as a whole and the supply chain. But yeah, I think that sums it up. I think she's, yeah.
Yeah, I was just wondering, as far as imports, that's a regulated system? People check in their catch and what they bring in? Or is there kind of a black market for dealing fish?
I wouldn't say that, I think most people are, tagging what they're importing and all those things. But there may be a black market that I'm not aware of, but we can still see, regardless, the things that are being tagged, the imports are increasing. So if not, then they'd be increasing even more.
The reason I say that is I just came back from a couple of the U.S. affiliated islands, and they were just coming in with buckets of fish.
Oh, really?
Kind of trade and deal.
Yeah.
They leave with beef is kind of what I've seen. So.
Okay. Yeah, I couldn't give you a straight answer on that, but.
Other questions?
I don't need a mic, it's in it. What kind of demographics on average were you looking at or seeing mostly for the buyers that you were interviewing and talking to?
Well, it's basically the same buyers that are down there at the auction every day. I would throw a number around like 20 buyers on average that
No,
I would see.
I mean like Hawaiians,
Who are they?
male, age.
Majority of them are locals, I think, with Hawaiians and stuff. But there are some white males in there. But yeah, I would say the majority of them are local. They've been in the business for a while, and even some of their families are in that business.
How many people did you talk to?
Of buyers? I don't know, like 10 to 15 probably.
Okay, cool. Thanks.
Yeah, I was wondering, this is a tough one, but a lot of fishermen they feel that the price that they're getting per pound is just too low to make a living. And I was wondering if you had much interface with the fishermen, talking about how they felt the structure and how they're dealing with it. And I guess I know that there's some boats that are now delivering in California on the Hawaiian license, and that's one possible way that they're doing this. They're leaving the state basically. It's that bad, I think. But there are claims that there's price fixing or maintaining a very low kind of level of cost structure for that. Any comments?
Yeah, well, as I mentioned, so I didn't gather a lot of information from fishermen, but what I did examine was some of those relationships that they have with buyers, which can jack up the price that they will receive per pound. And so some of those fishermen, they'll build these relationships with the buyers to make sure that they're getting a price that is manageable and sustainable for them to operate their vessels. But yeah, there's also, I know some of the fishermen will go into the auction and watch them bid on the thing, kind of an intimidation strategy, I think, maybe. But yeah, so there's no straight way that they're doing that, but yeah.
Sorry, but I guess there's red participants.
So, Chris, did you have a question?
Yeah. Sorry to wait for this, but could you go back to your exports slides? I wasn't quite sure what export meant.
So here we go. So exports is anything that is landed. Well, actually, there are transshipments, but it's not clear whether they're like the export could be an import that's just being exported, landed here and then exported. But for the majority, I believe, like where you see that spike, it's due to the big eye that was landed here was at a lower price, lower value there. So people were trying, at the mainland, for example, because that's where most of our exports are going. They were importing that there, so we were exporting because of the low value of the big eye that was being landed.
I'm curious why you weren't comparing imports to local supply, unless exports was a proxy for local.
Well, I would say the majority of the exports are local supply.
But it's a fraction of them that go to the U.S. mainland?
Of the exports?
Yeah.
The majority of our exports go to the U.S. mainland, I believe.
But it's a minority of our local supply, very much.
Yeah, very much. Most of the local supply stays here in Hawaii.
Okay.
Does that answer that?
I I was just curious why you weren't comparing imports to local production as opposed to exports.
Yeah.
Okay, if we can have a brief statement from there's mentor.
All right. Well, Jeppe, we greatly appreciate the hard work that you've done. We've tasked you with a job that's not easy. It's rare in the economic world to take data and actually look at it on your computer and then ask the stakeholders really what's going on. So I commend you for the efforts that you've put forth in actually interviewing people. So thank you.
We have Nadia Tenouri. She's from University of South Florida in Marine and Biological Conservation. She's a Hollings Scholar here with David Itano, and she's going to be talking about Fish Forever.
Okay, so my name is Nadia Tenouri, and I'm a student at the University of South Florida. My major is environmental biology, and my project is called Fish Forever, promoting best practices for the handling and release of recreationally caught sport fish. It is under the NOAA goal of healthy oceans, and I am in the Office of Sustainable Fisheries at the Honolulu office, and I'm working with David Itano. This project is done to encourage OMAO practices or best practices for handling, tagging, data collection, barotrauma, and other issues related to increasing the post-release survival for recreationally caught sport fish. We want to do this to promote additional recruitment of fish into the population. It fits into the Healthy Oceans objective for the sustainable fisheries and safe seafood for healthy populations and vibrant communities. And it's important for enhancing populations of economically important fish. It helps recruit new members into the population rather than removing them, and helps avoid overfishing and promote sustainability. It also promotes the collaborative efforts and communication between NOAA and fishing communities in Hawaii. I was interested in this project because human actions have a huge impact on populations, especially in fisheries, and fisheries are of huge importance to people, but they're at risk due to human exploitation and negative environmental impacts like habitat degradation, pollution, invasive species, and other things. This internship was a great place to learn about how managing important human-ocean interactions is done on the government level. And our hypothesis was that providing and encouraging fishermen with information and advice on best practices for handling, tagging, data collection, barotrauma, and selective release would promote long-term sustainability of Hawaii's fisheries. So I'm going to give a short background on Hawaii, which most of you probably already know. Hawaiians believe that all of nature is interconnected and must be respected. Sustainability in the land was promoted by the kahuna and the konohiki, which are the priests and land managers, who would restrict fishing of particular species during certain time periods. The old Ahupua'a management system divided Hawaii into districts running from the mountains to the sea for the local ali'i, which is the local chief, to care for. And fishermen held central roles in their community, supplying seafood to their district, which was supplemented by other staples, like taro and sweet potatoes. Fishermen traditionally maintained strong spiritual relationships with the ocean and constantly furthered their knowledge of the ecosystem and polished techniques like spearfishing, netting, and diving to locate fish. It operated on a cyclic schedule, living in harmony with the environment, but following the Great Mahele in 1848, this traditional system was changed a lot. Today, management of fisheries by supposedly out-of-touch regulators can be controversial. With the marginalization of the Ahupua'a system and an increase in commercial exploitation, managing fisheries has become a challenge, and fish stocks are said to be at best of 25% of what they were 100 years ago. An idea of recreational fishing in Hawaii is really different than it is in other places. Rather than fishing for pleasure,
Recreational fishing in Hawaii is usually done for subsistence or to share with other members of the community, which can really lead to the retention of really small fish, which are often a prized traditional food item. So this project aimed to inform and encourage local fishermen to promote and engage in pono fishing practices and to participate in the selective catch and release in an effort to give smaller fish a chance to grow and reproduce. It also encourages the voluntary release of some larger fish that are already reproducing, since they produce larger quantities of eggs compared to younger adults. It also promotes recruitment and increases fish populations. So, methodology. I started by gathering information from various primary and secondary sources about traditional Hawaiian fishing practices and the local importance of fish in daily life. Then I started researching current fishing practices and techniques in Hawaii. With that information, I created an annotated bibliography of that information for easy referencing for anyone who wants to use it and no employees or general public. I created outreach flyers then using PowerPoint for all the different categories of work I did, like proper handling techniques, proper release techniques, how you can tag fish. And then I'm going to make these flyers available to sustainable fisheries staff for modification with locally appropriate photos and rewording, the final formatting and finalization by the communications team. So this is one of the flyers I made on handling and release techniques. Catch and release fishing and management by slot size limits has been shown to be effective ways to increase the health and size of fish populations, but the release of captured fish is only beneficial if the fish that are released actually survive. So this flyer was created to inform fishermen about the proper techniques for handling and releasing captured fish to better capitalize on the population benefits. This is another flyer on minimizing post-release mortality. The chart summarizes the findings of various published studies on factors that influence the survival of captured and released fish. Those under the column labeled helpful were found to convey increased survival, while those listed as harmful decrease the chance that a fish will survive after release. The guide can be used as a handy way to decide what methods and techniques can be used as a more responsible and informed fisherman to increase post-release survival rates. This is another flyer for assessing the condition for release. It gives a list of reflex action mortality predictors, or RAMPs, that can be used to assess the condition of a fish for release. The mortality of a fish after release is significantly related to the impairment of reflexes, which is to say that fish who do not show normal reflexive behavior when stimulated are likely to have low survival if released. So this information can be used to help fishermen make better decisions on what fish are worth releasing after capture. This flyer is on deep sea fishing and barotrauma, which was used to inform fish about barotrauma, which is an injury caused by changes in pressure that occurs when fish are caught in deep waters and brought to the surface. For the purpose of catch and release, fish have to have the relatively high survival rates for it to be effective, so this handout focuses on what can be done to increase survival of fish suffering from barotrauma and what proper techniques can be used to return them to good depths, whether that be venting or using a descender. This flyer was used to educate fishermen on what's known about yellowfin tuna in the Hawaii region from scientific studies and how these studies can help inform fishermen on the pros and cons of different harvesting strategies to promote healthy tuna fisheries. This next flyer is on different types of tags, some of which are much more advanced and informative than others. They're commonly used by scientists to learn about a wide array of parameters of fish life history. But despite their common use, many fishermen are unclear as to the different types of tags and what information each of them can provide. So this flyer depicts and describes the most common fish tags and their uses. This next flyer is on tagging of pelagic fish and data recording. Large amounts of data have been obtained through voluntary tagging programs where fishermen report tagged animal captures as well as tagged fish themselves. In an effort to increase involvement in data quality and voluntary tag and release programs here in Hawaii, this flyer walks fishermen step by step through the process of tagging, both shoreline and pelagic fish. The second page gives information on what to do if a tagged fish is caught, including what information to record, and also what to do if any tagged or injured marine animal, turtle, or seabird is seen. This is similar to the previous flyer, except it is specific to billfish tagging, which requires a little bit different knowledge and techniques than tagging of other fish. So overall, a large annotated bibliography and 8 different Pono practices flyers were created, and they will be disseminated to Hawaiian fishermen. Through continued efforts by NOAA employees in Hawaii, we hope that these materials will encourage more fishermen to adopt and incorporate Pono practices into their fishing routine and amongst their peers. We hope fishermen will read the flyers and decide to incorporate Pono practices into their daily fishing routine to increase post-release survival, improve data collection, and allow further recruitment of fish into the population, assisting in long-term sustainability of Hawaii's fish stocks. Many local fishermen are interested and engaged in promoting local management, and thus Pono practices will hopefully appeal to them. The project supports NOAA's Healthy Oceans goals, specifically the objective for sustainable fisheries and safe seafood for healthy populations and vibrant communities, and it enhances existing efforts in Hawaii to work with fishermen on local management, and also adds to the abundant NOAA outreach materials. So the next steps will be to finalize the flyers. I only had 9 weeks, which, as all of you know, is not very much time. So the flyers will need to be edited and formatted and finalized by the sustainable fisheries staff and the communications team before they can be distributed to fishermen. Once they're ready for use, my mentor, David Itano, future volunteers, and NOAA outreach staff will hopefully make these flyers available to the public, while also educating them on the importance of local management and Pono practices. Also, an assessment of effectiveness of the program would be very favorable. A short survey can be done a few months after the fishermen have had a chance to incorporate these practices. Hypothetically, it could ask fishermen if they've read the flyers, learned anything from them, and incorporated them into their fishing. And it could also ask the fishermen if they think these flyers have done anything to change behaviors and attitudes toward fishing practices as a whole. Again, as a refresher, the objective was to educate fishermen on the Pono practices for handling, tagging, data collection, bear trauma, and selective release of fish to increase post-release survival and allow for the recruitment of fish into the population. So, did we meet our objective? We were able to construct the 8 different flyers on fishing practices, and after they're finalized and distributed in the near future, if they're used by the population, I would say that we did meet this objective. And I would like to say thank you to David Itano, my mentor, for his assistance and guidance in the project, which would not have been possible without his experience on fishing and fisheries issues. I would like to thank the Pacific Islands Regional Office of Sustainable Fisheries and the Science Center staff in Honolulu, who are all very helpful and informative in these projects. And I would like to thank the scholarship team, who has worked hard to give students financial assistance for college and the opportunity to intern with NOAA faculty on this program. So if there's any questions.
Questions for Nadia?
Wait, what's going?
I'm just curious, I know you're not able to disseminate these officially to the fishermen, but did you have any kind of unofficial conversations with any local fishermen about either the need or their own practices?
I went to some of the Pier 38 forums that Dave holds, and I listened to the talks that he does, and I didn't necessarily speak to the fishermen myself. That was what Dave was doing, but it did seem that they were interested and really engaged in local management, and that's something that they really wanted to do themselves. Like they understand the importance of managing fisheries, and they want their stocks to be sustainable. So I'm hopeful that it really will appeal to them, because talking to the fishermen, they really seem like it's something they are passionate about.
It's an informal question.
I was wondering if you had any contact when you were in Florida. What's the difference between the community here with the commercial, non-commercial fishermen in Florida?
In Florida, I think Hawaii is probably a lot different than everywhere in the United States as far as what is considered recreational. In Florida, most people don't fish for food. They really do it just to purely catch and release. Most people don't keep the fish. They fish and eat. I mean, some people do, but usually people just go out, usually in the rivers, not quite as much marine, and they fish for bass is really, really common. And they'll fish because they enjoy being out on the lakes and you know, sitting and fishing, and then they just usually throw them back. So it's really different, the reasons I think people fish here versus in Florida.
Before we move on, I'm wondering if you could tell us a bit about what your plans are for the year.
Well, I'm in my senior year now at the University of South Florida, so I'm going to finish my degree, and I'm interested in conservation, and especially in using indigenous knowledge and working with communities to reach goals. So I was looking into a few different programs, and I'm most interested in attending the University of Auckland in New Zealand in one of their PhD programs afterwards, and then I would like to work for either a government agency or maybe a nonprofit in conservation.
Undergrad, she just was scary, kind of smart. I thought, is this real? And then she came over, and then we got together and we talked quite a bit. And I learned, well, I had questions whether we would work that effectively together at first, because, well, she, nothing wrong with this, but she's a vegan, and extremely conservation minded, which we all are, of course. And, just had was coming from a different sort of background that I normally work with, but I was so pleased with her productivity and how much she learned in this experience and took on board. And I was also very glad that she was very self-motivated, because once we got going, she was off and away, and I had a very busy travel schedule this summer, and wasn't there often as much as I could be. But as part of my mentorship, I encouraged her to go to meetings, and she coincided with the council meeting, an SSC meeting, the Hawaii Conservation Alliance meetings, and I very much encouraged her to go to those as well. And I think she benefited greatly and learned a great deal. But tremendous job, I thought, and very quickly put these together. And again, they're templates that we'll use to populate with local pictures and whatnot. And I really, really appreciate the work you did. Thanks.
College in Chemistry and Geosciences, another of our PYSO interns. And her talk today is Processing of Calcification Accretion Units Retrieved from 2013 Northwest Hawaiian Island Reef.
So as was mentioned, my name is Chaplin. I'm a chemistry and geosciences double major at Williams College in Massachusetts. And this summer, I'm a PYSO intern in the Quenee Ecosystem Division at PYSO. And I'm working with Dr. Bernardo Vargas Angel and Alissa in this project, which is processing of calcification crushing units, or CALs as we like to call them, retrieved from the 2013 Northwestern Hawaiian Islands Reef Assessment Monitoring Program. So the CAL project is a way for us to study ocean acidification, which I'm sure pretty much all of you know about. But it is the change in the ocean's carbonate chemistry due to carbon dioxide absorption. And just to give you some background information on it, the ocean absorbs about 30% of the atmospheric carbon dioxide, and since pre-industrial times, the concentration of carbon dioxide in the atmosphere has been increasing. It used to be about 280 parts per million back then, whereas now it's more than 400 parts per million, and it just keeps increasing. So the shift in seawater chemistry that results from this absorption of carbon dioxide and also due to the corresponding increase in acidity, it's pretty difficult for calcifying organisms to build their skeletons and their shells, and it also slows down the rate of calcification. So the COW project helps us better understand and monitor the biological and chemical responses to ocean acidification in the natural environment versus the laboratory environment, which is why I think this project is really important. It's also exciting for me because pretty much all of my experience is in a lab versus working on data samples from the field. And CRED, or the Coral Reef Ecosystem Division, has study sites in over 50 islands and atolls around the Pacific Ocean. And this is part of the Pacific Reef Assessment Monitoring Program, or Pacific Grant. And the COW project is also part of this. So there are about 5 cows deployed per site, and usually 5 sites per island, so that's 25 cows per island. And in general, one region will have about 250 cows. So for example, the Mariana Islands will have 250 cows, or the American Samoa region will have 250 cows. So each cruise brings back that many cows. So these plays allow us to examine the accretion of calcium carbonate so that we can determine the rate at which classification is occurring. So what exactly is a cow? It's basically 2 square PVC plates stacked on top of each other, as you can see here. And it's connected by a screw that goes through, and it's deployed in a coral reef environment. And it's basically a surface upon which calcifying organisms can colonize, such as hard corals and CCA, or crystosperm algae. And this is what it looks like in blue. And like I said before, by measuring the amount of calcium carbonate accreted on these plates, we can determine the rate of calcification, because these are deployed for a certain period of time. It's 2 to 3 years between deployment and retrieval. So that helps us know. So in terms of what I've been doing this summer is processing cows from first the northwestern Hawaiian Islands, and later this week I'll be starting a set from the Mariana Islands. So far I've processed 5 sites from Lyndsey, one of which is not on this map, 5 sites from French frigate shoals, and 5 sites from Pearl and Hermes Atoll. And like I said, later this week we'll be bringing up a new set from Vaughan, so that'll be the start of the Mariana Islands. And while I won't be able to get through all of these samples like I had hoped, I'll probably be able to fish for 3 or 4 islands. So in general, the purpose of the COW project is to establish a baseline for calcium carbonate deposition on the coral reefs of the Pacific Ocean. And we're hypothesizing that net calcium carbonate accretion will vary based on the island and the region and the habitat in which the cow is deployed, and that this will change over time, most likely due to ocean acidification. And by monitoring these cows, we hope to detect changes over time in calcification rates and how these are associated to global climate change and ocean acidification. So I keep saying processing of cows, but what exactly does that mean? So basically what I've been doing this whole time is you take 1 cow, which we have to thaw first because it's frozen after it's retrieved from the ocean. We disassemble it, basically involves moving 2 crescent wrenches at once and unscrewing the plates from each other. Rinse them with fresh water. Then we photograph these plates, top and bottom, with and without ID tags. That's 8 photos per cow. And the purpose of the photographing is basically to get a sense of what was living on these plates and the percent cover. So what types of, if there was a lot of CCA or more fleshy material, things like that. Then we air dry it for at least 24 hours. Then pop it in the oven to dry for 24-hour periods. And in between each of these 24-hour periods, we weigh the plates, which makes it a pretty time-sensitive project. So basically, when the mass is measured at the end of 2 consecutive drying periods is within 0.1 grams of each other, that's when we're good to go to the next step, which is decalcification. And in this step, we put each plate in a Pyrex dish and cover them with 5% hydrochloric acid, which, yes, dissolves the carbonate, calcium carbonate on the plates. And so there's lots of bubbling, and to promote the process, we scrape the plates and mush it around and pulverize it with a mortar and pestle. And then heap out a new acid, and once the bubbles stop forming, then we take what's left, which is the fleshy material, and filter it. What's left looks like that. And we air dry this for 24 hours, then pop in the oven again. And just like with the cow plates, we measure the weight in between each of the drying periods. And like before, when the masses measure the end of 2 of these successive drying periods, it's within 41 grams, they're put away for archiving in Ziploc bags. So this whole process takes about 3 weeks, and we don't do it for each cow. We usually do it in sets of 50, which ends up being about 1 island. So we do stagger the process, so each week we thaw a new set of cows. So we took a break this week, but next week we'll be starting with Mariana's, and then with Vaughan and others. So with the data obtained from the processing with the cows and also the data from the water chemistry, we hope to answer the following questions. First, why do differences in calcification oppression occur? Second, how does this affect the community structure? And finally, how will ocean acidification affect the rate of accretion in the future? So while we can't answer all of these questions now, we do have some idea of what the answer might be for a few of them. And there's one set of cows processed prior to the ones that I'm processing now, which was from the American Samoa ramp cruise in 2012. And that data showed that the average calcification rate among the different islands that were visited during this cruise, that the calcification rate varied. It was different, as you can see here. But the rate of calcification among different sites within one island didn't vary significantly. So one potential reason for this difference in calcification rate might be ecosystem type. And they found that the rate of calcification was faster in full reef ecosystems versus lagoon environments. So it's possible that we might see this for the northwestern Hawaiian Island and Mariana samples as well, but we're not really sure. This is just preliminary data, and this project is pretty new. But it is important for us to establish a baseline for this calcium carbonate accretion, because if we do that now, then we can identify changes in the future and pretty much how severe ocean acidification is and how fast it's acting. So I'd like to thank Dr. Bernardo Vargas Angel and Alissa for their mentorship and support. I'd like to thank Don Kobayashi for organizing this event and for coordinating the internship. And I'd like to thank NOAA, PYSO, and the team. Thank you.
Quickly, the cow, is there a reason that you go with a inorganic substance like PVC versus something like natural rock or with contours? I was just wondering if there's been a study comparing those two sampling processes.
I'm not sure if there's a set study, but they have tried different material like regular tiles or even terracotta, but they are breakable, and PVC is pretty cheap to come by, and it calcium carbonate does accrete on it pretty steadily, so that's why I was trying.
So the design of the double plate, is that just to give you replicates, or are different types of organisms differing between the top plate and the bottom plate?
Yeah, also replicates, and I mean there is a shadow covering the bottom plate as well. So, but each site, like I said, has 5 cows, so that is also even more replicates.
I was just wondering if they know anything about the things living in the area. Like, did they time when they put the cow down, when they took it away? Like, is it when corals are spawning, or it's just kind of?
I don't think it has anything to do with when they're spawning, but there are different organisms that live on them depending on the location.
What kind of organisms?
What's that?
What kind of organisms?
We haven't looked. I mean, I haven't looked into that during my internship. How do you guys account for the differences in depth for all the different samples? Are you kind of trying to standardize that between the different sites? Or?
Yeah, they're usually deployed in like a 10 to 15 meter depth range. So, yeah, because it would be, we wouldn't know if it was, all over the place, but we do try to standardize it. Thank you. And before you go, if you could just tell us quickly what your plans are.
Okay, I have 1 more year at Olivia College, and then I plan to take 1 or 2 years to gain some more experience, hopefully in the field maybe. And then I plan to apply to graduate school to study marine chemistry and geochemistry.
Hi everyone, I'm Olivia and I'm one of Alissa's co-mentors at CRED. I actually just really want to use this opportunity to thank Alice for all of the hard work that she's done. I think that she is truly instrumental in getting a lot of our calcification equation units processed in such a short amount of time. And I feel like we truly lucked out with her in that she has some great qualities in a young scientist that sometimes is hard to come by. She's very reliable and she's highly motivated, and that she really took this project as her own. She basically kind of really ran away with it, because there were some times that I wasn't able to be there with her due to other responsibilities within the division. So I feel that she has really helped us in a way where we progress further with this project, purely because she's here. So I thank you for choosing to work with us over the summer, and I hope that you learn from us as much as we learn from you. So thanks.
She's from University of California, Berkeley in marine science. She's also the last of the PYSO interns to give her talk to us today. Her mentor for this summer has been Reka Domokos, and they have been studying the Deep 7 improved identification of bottom fish using active acoustics.
Yeah, so I think to cover where I go to school or anything like that. I'm Heidi, and I go to UC Berkeley and I'm studying marine science. So what are bottom fish? So you can see here that there's a lot of different kinds of bottom fish. The deep 7 are these specific species that you see down here, but as you can see by looking at this, they are very similar in physiology to other kinds of bottom fish. And they're basically, these are a bunch of different kinds of snapper and grouper. And the deep 7 are ones that we are particularly interested in because we like to eat them. And so I looked up a study, it was in 2008, just to get an idea, because my research isn't primarily on the market, but just to talk about why we care about these 7. And this study that I was looking at said that 54% of the fisheries off the Hawaiian Islands were fishing for the deep 7. And we keep, there's a limit on how many of them are allowed to fish be a fish in a year, and that limit is set based on what we know about populations that are out there. So it's really important that we know our stock assessment. So then I talk about what is active acoustics, right? A lot of people aren't familiar with that. So marine bioacoustics in general is using sound in the ocean to study the ocean environment or the biology or something like that. Active acoustics is when you make a sound and you listen back for that, and you learn about it by what comes back to you. So here on the upper right-hand side, this left-hand view, is an example of the hydrophones that are being used for these studies, and they're used at different frequencies, and we get different responses at different frequencies from the same things. Down on this side, you'll see an echogram. This is basically what I've been staring at all summer, is pictures like this. And just as this cartoon should show you, we make a ping out, and the echo that comes back on the fish gives us this echogram. Basically, if you go horizontally across the echogram, that's with time, with relation to time and movement. So, and so I've been spending my time looking at target strength of fish. If you look at this echogram, you'll see that there's some places across the lines where the echo was stronger, and there's certain patterns and functions that are used to determine when these are fish tracks. And so the target strength of fish can be affected by the size, presence of the swim bladder, the angle that the fish is at. And so by looking at the target strength, we can try to determine what kind of fish it is, where like how big it is, and so mainly we've been comparing that with areas where we have some sort of ground toothing. As you can see, 3 of the types of ground toothing that we have been talking with or trying to do is optical. Ideally, we have 2 cameras. It was part of our data where we only had 1 camera, so we couldn't get sizes. We could only get species for those kinds. But basically, we'd be looking at the echogram where we had an AUV track, for example, and there's another person who looked for AUV tracks or looked at the AUV data and gave us what kind of fish it is, and then I would look through the echogram and find the target strength. And we also had information from fishing data, and so the fishing data could be matched up with the echogram, and the fishing, basically they would jot down exactly what time the fish came up on the reel, and they would give measurements of species and size. So this is the data that Rekha had when I was starting on this project, and so this basically what we're looking at. Okay, so this bottom line is physicalist. That is what we would expect to see for a fish with a controllable swim bladder. So they can control the size of their swim bladder as they go up and down in the water column. It's a very general equation, and it's not relating to this in any way to the species of these fish. Kelly Benoit-Bird, who is a researcher at OSU, she did some work on bottom water fish, and she came up with this measurement. Now, part of the reason that her target strength may be so much stronger is potentially because she was using a different kind of system. Earlier I mentioned that we were working at those different frequencies specifically. She was working at a broadband system, which means that it's sweeping off. Basically, it's using a lot of different frequencies at once. So there's less knowledge on how broadband systems measure target strength differently. So that might be theoretically why. Basically, Rekha had already done these TS measurements of this small fish which they caught and they pulled behind the boat, and they done echograms at the same time. And a couple other, the bot cam was one of these visual observations and some fishing points. And with that information, she can come up with this line, which is similar in slope to with Dr. Benoit-Bird, but it's as you can see, the target strengths are much closer to what we would expect from a physicalist. So basically, what I've done this summer is make this graph, so I've looked at target strengths of fish in a lot of different, in 2 different cruises, 1306 and 1302, which were a year and 2 years ago, and the line I have here is actually only taking into account the kinds of fish that we have that are bottom fish. Of the deep 7, there's 3 of them that we had in observations. And the other points that are shown are of other types of fish. So we have an idea of how they relate to the equation, but the actual, the white line is just using the data from the bottom fish. So you can see that during fishing, we primarily got opaka in a pretty broad range, but in the same size fork length. During the optical, we mainly got a Pelu, which is not a deep 7. And I combined the data from these 3 with RECAs to create this line. And so it's in terms of target strength, it's still higher, but its slope is a bit more like the physicist. So that's looking at the individual fish. The next step that I'm working on for the rest of the summer is looking at the shapes of the schools and trying to see if there's another way to assess what kind of species it is. So looking at, for example, here, this is, okay, so the grid doesn't look even, so that's because it's by vessel log distance. So it depends on the velocity of the vessel and how it's going to look in terms of the number of things that are sent out during that distance. So this here is 10 meters, since you can't probably read the thing. But you can see that the shape here is like that the fish are really flat to the bottom. They're within, 10 to 20 meters of the bottom, all of them, and it's pretty wide. But yet over here, it's pretty vertical, right? They're kind of almost stacked on top of each other. You can see like the targets there. And then sometimes it has these strange shapes that aren't as clear in what kind of one they have. So I've been sorting I started out by sorting those into very technical terms. Bottom blobs, mid-range blobs, vertical and flat bottom. But that's basically like, something that had a strange shape on the bottom versus what we're going to find midway through the water column, which is not likely to be bottom fish. And then there's definitely a different type of behavior if you see a vertically stacked school to a flat to the bottom school. Looking at if there is statistical significance to which kind of species are caught or seen in these different schools. I'm looking for other ways to use other information I have about the schools and the rock that's at the bottom and the habitat of the fish to see if we can identify the schools better by just looking at them. That's later. So that's pretty much my project. The last slides, Dawn told us to talk about our features. Oh, okay. This is a collage of my feature. I think this is what I have in common with everybody right here. So in a month and a half, I'm getting married. And then at the end of December, I'm graduating, so this is a really big year for me. And then this is my self-portrait, because I'm planning on really spending some time on honing my programming skills before I apply to grad school. And I'm hoping to go on to continue to study bioacoustics. So. I want to thank Rekha, who I've been working with. She's been putting up with me all summer, and I pop into her office every single day. And Dawn, who's been not only organized this event, but also been a great resource to come to with questions like these.
Questions for Heidi?
Okay, with regards to your fish school behavior, have you guys talked to local fishermen? Because I know they're a really valuable resource when it comes to the behavior of the deep 7. A lot of times they're able to use their echo sounders, and based on the fish behavior, they know what species it is. So
that's a cool idea. We have not talked to local fishermen. I have another month here, so that might be possible.
Well, yeah, I have. Yeah, I have talked to some of the fishermen and tried to identify based on their experience, because they use echo sanders. They're not as sophisticated as these ones we use for science, but they also look at the fish. They call them fish finders to see where to go fishing, and so they have a lot of experience of trying to identify identify which type of species and how they look on the echograms.
Thanks, Rebecca.
Other questions for Heidi?
Yes.
Just coming. We want to use the mic so that the people on the WebEx can hear.
Hello?
Yep, you're good.
Hi.
Here.
I just want a clarification on, do you use, when you do the acoustics, do you use another method with the acoustics like bot cam and the fishing?
Yeah, so that's what the, so all the data points that we have where we have measured size, either we had fishing data of fish that had been brought up to the surface and we logged the time and the size of it, or we had an AUV or a bot cam going along the bottom, and there's another person who did the optical work of going through the video and measuring the size whenever we had two cameras. It was obviously limited to two cameras to measure the size. So any data points I have were based on the combination of the effort.
Yeah, to the point about school shape and size and appearance. Fishermen, well, I do a bit of bottom fishing too, and sometimes you catch certain species on the bottom and sometimes it's in mid-water or higher up. I was wondering if with target strength, and maybe this is for Rekka too, are you able to see, for instance, like alpaca when they're on the bottom, in a bottom behavior, and then in a mid-water behavior, and so what I'm saying is that one species can have many different school shapes probably, and were you able to see that?
So I'm limited to what we can ground truth, and all of the fishing and the camera work was done on the bottom. So the species that I can identify with the data from these two cruises is all within the bottom area. So I don't doubt that that would be true if we had some mid-water data, but we don't have the species recognition for that.
Okay.
Thanks. Rekka wants to say a few words about that.
Yeah, we don't have enough data from.
Oh, I meant about the summer internship.
Oh, the summer internship, yeah.
I'm sure we can talk for hours about one fish.
Yeah, I just like to say that I'm very satisfied with Heidi's performance this summer. She's been showing a lot of motivation and also a lot of initiative to looking at the data from all different angles to help us identify these acoustic descriptors for the deep 7, which will better enable us to estimate the bottom fish of these economically important species. And eventually, maybe acoustics will become a very cost-effective way of monitoring the biomass of these species that are heavily fished in these areas. So thank you.
My name is Matthew Vandersandy. I work for the Pacific Islands Fisheries Science Center in the director's office. And we are going to start session 4. There we go, that's better. Thank you everybody for being here. So first up, we have Taylor Heckman. She is from Willamette University studying biology, and she is at the Pacific Islands Fisheries Science Center, and her mentor is Angie Kaufman. And the title of her presentation is Hawaiian Monk Seal Health and Disease Program.
Hi everyone. As mentioned, my name is Taylor Heckman, and I was volunteering this summer as an intern for the Hawaiian Monk Seal Health and Disease Program, which is one of the main programs for the Hawaiian Monk Seal Research Program, along with foraging and population assessment. So I'll be giving my presentation on the program and my involvement in it. Some background on the Hawaiian monk seal. Hawaiian monk seals are one of the 3 species in the genus Menacus, the oldest of all monk seal or seal genera. The Caribbean monk seal went extinct in the 1950s, and the Mediterranean monk seal is in danger of becoming that way too, as it has a population of less than 500. The Hawaiian monk seal is endemic to Hawaii and has a population of around 1,100, Most of this population is in the northwestern Hawaiian Islands, where there's an annual decline of around 4%. However, there is a growing population in the main Hawaiian Islands consisting of about 150 seals. Adult seals grow to around 7 to 7.5 feet and can live for 25 to 30 years. They're benthic feeders and subsist on a diet of things including fish and crustaceans. And they were nearly hunted to extinction in the 19th century and now face a host of other issues, including starvation, low genetic diversity, and human interaction. So the Health and Disease Program investigates the impact of parasites, infectious diseases, and toxins on the monk seal population. And as the population in the main Hawaiian Island grows, it leads to increasing risk that a disease will spread throughout the entire species, because main Hawaiian monk seals haul out in areas around people, around feral animals, and in areas where runoff interacts with the environment. So the HDP works to prevent a mass mortality event and to investigate current threats to improve seal survival. So the HDP provides infectious disease surveillance, and it responds to any sick, hook, entangled, dead, or otherwise injured monk seal with medical assistance and disease assessment. Some of the diseases that are relevant to the program and under monitoring are brucellosis, toxoplasmosis, leptospirosis, and distemper virus. This section will be a little longer because it's what I'm particularly interested in. So leptospirosis is very widespread in Hawaii. You can contract it through indirect or direct contact with urine from one of the primary vectors, or like mongoose or rodents. And the significance of leptospirosis on monk seals is not yet clear, but antibodies for leptospirus species have been found in Hawaiian monk seals, indicating that they have been exposed to it. Distemper virus has caused mass mortalities in marine mammal populations in the past. For example, the Phocine distemper virus caused the death of 20,000 harbor seals in northwestern Europe in 1988. Luckily, it's rarely diagnosed in pets on the islands. There have not been any antibodies detected in Hawaiian monk seals yet, but because of its role in past mass mortalities, the population continues to be screened for it. Toxoplasmosis is caused by a protozoan parasite, Toxoplasma gondii. The definitive hosts of the parasite are members of the felid family, so domestic cats and their relatives. And monk seals and other humans can contract, or really any warm-blooded mammal can contract the parasite and the subsequent disease. Monk seals can become infected through contact with water contaminated by cat feces carrying the oocytes, or by eating contaminated prey. Several seal mortalities have been contributed to toxoplasmosis, and one such seal had cerebral and visceral lesions, and tachyzoites were found in its organs, like its brain and lymph nodes. And so the potential impact on Hawaiian monk seals continues to be investigated and monitored. The last disease most under consideration is brucellosis, which is caused by members of the Brucella genus, which are gram-negative bacterial pathogens of mammals. And infections in marine mammals have been reasonably recently investigated, but the bacteria are widespread, which indicates they've been present in those animals for quite a long period of time. The clinical significance of the species that affects marine mammals is not yet clear, because although some Brucella has been isolated from animals with symptoms such as placentitis, meningoencephalitis, and abscesses, it's also been isolated from perfectly healthy animals. Antibodies for Brucella species have been found in the Hawaiian monk seal, but the effect of the bacteria and the extent of its presence in the population is unclear, and it's unknown whether or not Brucella is contributing to population decline through reproductive failure issues. So this is just a chart showing the distribution of Brucella species and their target organisms, more or less. And you can see B. pinnipedalis and B. seti affect dolphins, seals, and the like. So gastrointestinal parasites are a common issue for monk seals. They're often host to them, and parasites are detrimental to the seal's ability to absorb food and nutrients, which coupled with issues accessing prey in the first place can lead to emaciation and starvation. Juvenile seals are particularly at risk. The Health and Disease Program is currently testing deworming medicine on selected juvenile seals, and if it proves to be beneficial, it may be implicated more in the future. So far, it hasn't caused any harm, so the program continues. Some of the toxins that are being monitored in monk seal populations include organochlorines and ciguatoxins. Organochlorines, OCs, are used as pesticides as a means to control termites and mosquitoes. OCs accumulate in monk seal blood and tissue after they consume contaminated prey. Few seals under study have shown levels high enough to cause health effects like immunosuppression, but it continues to be monitored. Ciguatoxins are produced by microalgae, they're neurotoxins, and recent research has found detectable levels in the blood of 19% of 55 seals studied, and as well as in dead stranded animals. So significant levels are there, but the impact of the toxin is not yet known. So my involvement, the work I've done with the MSRP this summer and in the past has included the CritterCam project, sample organization, necropsy assistance, data entry, and some live animal care. I volunteered for the program because of my interest in marine pathogens, and throughout the summer I was exposed to new techniques, information and skills, as well as the complicated process of collecting and analyzing samples. I highly recommend the experience. My involvement with NOAA and the monk seal research program started when I won an essay contest to be a student researcher for the Huike Maka monk seal CritterCam project. I was lucky enough to be able to accompany the team to Molokai to help with the deployment and recapture of the cameras and learn some of how to process blood and tissue samples. The CritterCam project is working to augment our knowledge of monk seal behaviors and feeding habits, serving the dual purpose of providing helpful conservation information and to dispel some of the myths that have caused tension between people and seals. A lot of what I did this summer is sample management. The Health and Disease Program has over 60,000 samples dating back from the 1980s, and these thousands of samples are irreplaceable as they are from a highly endangered animal, and many of the samples come from seals that are now dead. So all of the information from the sample is entered into a FreezerWorks database, and the samples themselves are stored either at -80 degrees in the ultra freezers or in the dry archives. And the organization is really crucial because the samples are sent all across the country for specific testing, and if they were to be lost, it would be extremely detrimental towards the research. One of the more exciting but unfortunate parts of the HDP experience is necropsies. Necropsies are very important. They're essentially an autopsy of an animal, in this case a monk seal, and for such an endangered animal, it's really important to get as much information about the cause of mortality as possible. So samples are taken from every part of the body and are processed to identify abnormalities or presence of things like toxins and disease. Throughout the necropsy, an intensive physical and external examination is conducted by the veterinarian. So, future endeavors and a fun comic making light of a more serious issue. I'm starting my sophomore year at Willamette University, so I will be applying to the Hollings scholarship with the hope of being able to continue working with NOAA in the future. Even if I'm not successful there, I hope to return more to my own project furthering research with kind of my own project soon, possibly in the field of marine microbiology, where I've been involved in the past, and more school. Always so. I'd like to thank Angie and Charles and Mark and the rest of the Monk Seal program for giving me such incredible opportunities, and Dawn for putting this together, and you all for providing me with your time and attention. Any questions?
Alright, so because we're down to one mic, I'll ask the interns just briefly restate the question so the folks listening online can hear the question. So, anybody?
Did you have any connection with the Monk Seal sighting or reporting system that they have?
The volunteer program?
Yeah, where you just, I guess when you see a monk seal out in the wild, you claim what tag they had on it?
Oh, well, you know, anyone can do that. They have a number online that you can call if you see a monk seal.
Were you connected with that number at all?
I don't think so.
Yeah.
Oh, no, I didn't answer the phone or anything, no.
Yeah, okay.
Yeah, but they definitely respond to those as part of the program. Angie got called out a couple times for various hook seals and seals in trouble.
More questions?
So you mentioned you worked on the biosampling data set. What did you enter data? Did you reorganize it? Not reorganize it. Did you organize it?
I did both. So there's several different data set projects that were kind of going on, and one is the constant entering of new data as it comes back from like the cruise, and that all has to be entered in, and the samples added, and the aliquots, et cetera, and the other one is in the transfer to the new facility. The ultra freezers got very, very disorganized. So the idea will be that it'll essentially be like a library where everything has its place in the freezers, and you can check it out, and it'll probably be barcoded, and so it'll be a very clean process, and so we'll lose any of the ambiguity that might come from losing a sample or misplacing it or not knowing where it's from, kind of thing, and then entering old data and anything that hasn't been updated into the new system.
Angie, would you like to come down and say a few words about your mentee?
Thanks. We first met Taylor last summer, as she mentioned, coming on a trip with us to Molokai and help with critter camming, and she just really stood out to us with her enthusiasm and her ability to really pick up our protocols, and was pretty outstanding with her positive attitude. So when she said she wanted to come back and volunteer for us, I snatched her up as fast as I could. And I couldn't be happier that she was here all summer, and I really hope to see her again. And she's been fantastic for us.
All right, up next we have Alex Fonts. Alex attends Texas A&M and Corpus Christi, studying information technology, and he is an intern this summer at NOS. He's a Hollings scholar. His mentor is Rob O'Connor, I see down there, and the title of his presentation is Geospatial Data Librarian. Alex.
Like you said, my name is Alex Fonts. My project this summer was working as a geospatial data librarian. First, before I get started, I want to say thank you to the other interns who have done like really cool like research and scientific projects. As I go through my presentation, you'll see that mine's a little bit different. It's not about, well, it was kind of about the projects, but it was also about the position as a whole. So I think it's really awesome what you guys have done, and it's really cool to learn about all of that. So anyways, so I worked as a geospatial data librarian this summer. My division I worked for was the Habitat Conservation Division, which was underneath the Pacific Island Regional Office. kind of a quick overview of what I'm going to talk about. I'm going to kind of give an introduction, talk about the background of my position, which I kind of already started doing, talk about kind of the main encompassing task of the position, talk about some of the projects I was connected to, kind of some results from the projects, next steps, the connection to NOAA's missions, and kind of talk about the experience as a whole. To start off, this is kind of a slide that will be a little more interesting in DC, since we all know where Hawaii is. I thought I'd tell the people in Silver Springs what we did this summer and where we were, so I'll just kind of make sure they know exactly where the island of Oahu is, where Ford Island is, and all of that jazz. So I'm glad we're all clear on that one. So to introduce the position, so I worked as a geospatial data librarian, doing a lot of work with the organization, and working with the mass amount of GIS data that's out there. If you don't know what GIS is, it's a Geographic Information System. Logging and organizing a lot of spatial data that can be used for tons and tons of different things, to help so many divisions out in NOAA. And so what I worked on a lot this summer was working on data, creating shape files for a bunch of different divisions and projects, and kind of streamlining the processes so we can share the data with everybody, because sharing data is important. It was really awesome getting to take some of the GIS knowledge I have from going to school and university and stuff like that, and some of my past experiences, and being able to kind of move it into a marine conservation-based mindset, which was awesome because I've always been in love with the ocean. So anyways, a little bit redundant, but yeah, so working on documenting the data, making sure that the data is open for everybody to use, because if you're holding back the data or not sharing it with anybody, not everybody can benefit from the research that's been done. And then a lot of the work that I did this summer was not only organizing what has already been put together, but also updating spatial databases for two of my projects. So the main encompassing task, redundancy, is I spent a lot of time creating, documenting, and updating the data sets that I worked on. The three main projects that I worked on this summer was a cumulative impact permit mapping project, general geospatial solutions that would come to me via my mentor, and working on the Habitat Blueprint project on the northwestern side of the main island of Hawaii. And so to start with the cumulative impact permit mapping, it was through HCD. I worked with the essential fish habitats. Basically, these permits are sent to EFH when a marine construction or anything that is can influence or affect an essential fish habitat. A permit is sent into this group, and it's been these permits have been sent in since 1999 from the database I worked with, coming from the Army Corps of Engineers, Department of Health, Department of Transportation, military, tons of non-federally connected groups, kind of sending these permits in, and they're for all over the Pacific, but I kind of focused on the Hawaiian Islands and the Northwest Hawaiian Islands in the monument. So my job was to take this database that was already created, kind of giving a description of where it is, kind of a permit number, who turned it in, and taking that information and doing my best to find a coordinate for them, for each permit. And I worked with and to georeference the permit so that we could create a map, so we can, in the end, show these different groups, these different interest groups, such as Army Corps of Engineers, Department of Health, where the biggest impacts are being made in Hawaii. So I georeferenced this all summer. It's kind of one of my side projects I was always working on. There were over 2,500 permits that I got to look at, and every single one of them was beautiful. It was really cool because it was like going on a self-guided tour throughout Hawaii and throughout the Pacific at all times. And so basically I took and created a database for them, entered in coordinates, which is that's such a beautiful part of this project, and kind of put a year attribute to it. And this is one of my outputs. So this is obviously the state of Hawaii, and you can see every single one of these points are connected to a year and a permit. And so you can obviously see that for the next one, once now that these maps have been created, you can see hot spots where a lot of marine construction is being done. I'm gonna get them to pop up. There we go. Where obviously there's a lot of influence by humans and construction. You got Waikiki, you got Pearl Harbor, the Marine Corps base, and so hopefully these maps can be used when they start talking with Army Corps of Engineers, Department of Health, and say, you know, it's really obvious that we're doing a lot of work in these areas, or in the past, 3 years, it's really obvious that we've started working a lot more and there's been a lot more impact, and let's make sure we're not continuing on with that trend, and if we do, let's make sure we're careful. So that was one of my main projects. One of my other projects that I worked on this summer was working, kind of just doing general geospatial solutions for my mentor. I kind of had responsibilities to support Rob and the documentation and creation of geospatial data to be used in the GIS that NOAA has to support the staff, not only in our office, but all the other offices that sent the requests to Rob. So one of the first examples, I did a good number of these, but I just did a couple examples, just creating a few shape files. This is when they were proposing to change some long line, I guess, areas that were, I guess you'd say, they're starting to restrict the use, and so just kind of creating some example layouts for presentations. I helped create a simple polygon layer for some EFH areas in American Samoa. And so that was kind of interesting because I got to use past GIS knowledge that I had to help create these projects, or not these projects, these shapefiles to be used for other projects. And last but not least, I worked with the Habitat Blueprint project in West Hawaii location. This is what took up a lot of kind of this middle to end of my internship here. The Habitat Blueprint project, if you're not, I guess, aware of what it is, it's the initiative that NOAA has started this year. They picked out, I think, about 12 locations around the nation to focus all their efforts and research that's been done in the past on one location to have a noticeable impact in 3 to 5 years. So what I did was I helped, along with another intern who will be after me, taking and collecting a lot of data from not only our office, but from other interest groups, and kind of putting that all together on a database that can be used to help the interest groups in the area make decisions and see exactly what's going on. I've got so a lot of my responsibilities were to retrieve the data, kind of put it into a little bit of a database of a ton of shapefiles. And this is one of our output maps that is kind of starting out. This is just land covered in the area, and so we had tons and tons of these shapefiles that we put together so that the interest groups could see what we're working on, and so that we can share the data with them and do the best to work together. We went to the Big Island. It was really awesome getting to see the sites that we were working on and the data we're collecting. When we went out there, we met with the interest groups, figured out what they want to see out of the project, see what data that they can share, and see how they want to be benefited from this, along with how they can help benefit NOAA. It was beautiful, it was awesome. Here's some pictures that we took when we were out there. And so the blueprint experience as a whole, learned how to properly assimilate all the resources we can collect through NOAA and through these other interest groups, to kind of see the importance of how this project can be shared with everybody so that it can be for the best of the environment being looked at. Next steps, which Machino's going to talk about next, is to place the data onto an online GIS database so that these other interest groups can help move the project forward as we get more research done. And so as a results for this internship this summer, it's been an awesome opportunity to get into this position and to kind of learn how to be a GIS professional in a government facility, learning about the different government ways that things are done, and to kind of get hands-on GIS work and to work with project management, and it's been really rewarding. And because my project was kind of oversaw a bunch of different, or my position oversaw a bunch of different projects, kind of connections to all 3 NOAA mission statements were made. And I'd like to thank my mentor Rob, the co-interns that I worked with this summer, the HCD lead, Jerry, the other Blueprint contacts, the IRC, and the Hollings scholarship team, along with everybody for your time. Any questions? Okay.
Any questions for Alex? I guess I have one. Working with this geospatial data in the islands, coming from the north, did you encounter any challenges?
One of the cool things about working with the people on the Big Island was same thing as working on Oahu, but even more on the Big Island was the community connections with the data. You can't say like, oh, there's a stream here, we're just gonna map it, or just give me the data. There's history behind the data, there's ties to the information they're giving us. So it was kind of more of a, instead of just handing you a shapefile or handing you data, it was kind of like I'm handing over this place that I care about. And so that was really cool, kind of seeing that there was a lot more to it than just a file that I got over an email, kind of a thing. Perfect. Thank you very much.
Hi, Rob O'Connor. What can I say about Alex? I didn't prepare anything really, but he worked great independently. Like he said, he had a good GIS background coming into the position, so he could hit the ground running and start working on things that we needed done right away, which was really useful. I didn't have to do too much training or poking and prodding to get him going. Just being in the office, he was really respectful of everybody and had good interpersonal communication skills. I think that brought a lot to the mentorship, and like you mentioned before, the cultural aspect of everything, I think that was a really good insight for him, something he might not have gotten in Texas. So, thanks, Alex.
All right, moving along. We have Mashino Hizabayashi. My bad. She attends Clark University and is studying geography. She is here working with NOAA as part of NOS, the Marsh-Muskowski Fellowship. Her mentor is Doug Harper and Rob O'Connor. And the title of Mashino's presentation is NOAA's Sentinel Site Program and Habitat Blueprint from Observation to Stewardship. All right, thank you. Use this one, the other one.
Hi. Good. Yeah, as Alex said, it has been really awesome listening to all of your presentations. We have 3 more to go, so yeah, I'll start. So my name is Michino, as he has introduced me, and I go to Clark University, and my internship was under the Pacific Services Center with Doug Harper as my mentor. So today, I'll just introduce myself and the project objectives. So Alex talked about it, but we work together on the same project. And Alex has done a great job kind of explaining the big picture of the Habitat Blueprint project. So I will focus more on what ArcGIS Online is and the progress update of the project so far. I will talk about next steps and then conclude the presentation. So here's a little bit about myself before I jump into the project. So I go to Clark University, which is in Worcester, Massachusetts. You can see that on the map, and it's the 2nd largest city in New England after Boston, if you didn't know. And Clark is big on cytology, and we have a statue of Sigmund Freud. fun fact. And, I am a geography major, and I am pursuing a 5th year BA MA program in GIS. And I am not a Hollings scholar, and I'm here with a Marsh Mozakowski fellowship from my school, so I'm happy to be here. So, as Alex has mentioned, Sentinel programs, Sentinel Site Program and Habitat Blueprint are both NOAA efforts to coordinate NOAA offices and build partnerships with other local and federal partners to support and drive the initiatives in specific sites. And they are 2 separate programs, with Sentinel Site programs focusing more on climate change and Habitat Blueprint more on coastal and marine habitat loss and degradation. But as you can see from the map, on West Hawaii, the project boundaries overlap, so that's, yeah. And because there are so many restoration and conservation projects going on in the area, the first steps are to determine what works are being done, where gaps exist, and what can be done to address those gaps. So, in order to identify priority management needs and opportunities for NOAA to support, sharing information and GIS data becomes very important. And GIS, as Alex has explained, is a geographic information system which is a really powerful tool with many different applications and spatial analysis capabilities. It's great, but sometimes with a lot of researches and projects conducted and managed by so many different agencies, getting the right data can be very difficult and energy and time consuming. So my summer project's goal was to assist with sharing information and identifying spatial solutions through the development of mapping products using GIS. Essentially so that useful data can easily be shared, accessed, and updated by all parties involved. And so how do we do that? So ArcGIS Online is what NOAA decided to utilize. It is a cloud-based platform for making maps and sharing maps and applications and other geographic data and content. It is a fairly new development pushed by Esri, and so GIS can be more user-friendly and accessible by many different users, not just the geospatial professionals. And here, it's a little bit pixelated, but it's useful for streamlining organizational data, collaborating with different data users like managers and policymakers. And it's also really useful for sharing information on websites and through social media. So a chunk of what Alex and I worked on this summer for this project was something I guess we called metadata development. Metadata is information about the data, and it's really important because it's really important to make sure that that is also available with the data, because you have to know what you're looking at. So it's really useful so that the users can determine whether a given data set is appropriate for their purposes. And I have these pictures because metadata is kind of like the nutrition facts table that you can find on your cereal boxes. You can tell like what's in it, where, how, and when it was made, and all the information needed for you to decide like, can I recommend this to somebody else, kind of thing. And we did a lot of data organization, and these are, you can't really see them, but some of the screenshots that I took of Google Excel sheets that Alex and I used to keep track of everything. So we categorized the layers into subtopics, and each row had basic information about the layer, like where it came from, short description of the layer, and where the data can be downloaded from. We also kept notes on if the metadata is good enough, or if we needed to do some spatial processing of the data. And secondly, I've also been cataloging a database that PSC has of the region of West Hawaii. It's really big, but there are a lot of useful data in there. So I started cataloging, so more useful data layers can be added to this project. And I also have been learning about different capabilities of AI, ArcGIS Online, and I took notes on what different web application templates are there that ArcGIS Online offers, so we can see which one's the most appropriate for this project. And this is kind of where I am right now. So as Alex mentioned, we went to the Big Island and we met with all of these different partners who are involved in the area. And based on their inputs of like what's going to be most useful for them, we recategorized all the layers into these 9 subtopics, and I created web maps on ArcGIS Online. But there, as NOAA is a government agency, there's a lot of procedures to go through before actually publicizing anything, which is good. So NOAA has a organizational account for ArcGIS Online, which is called NOAA Geo Platform. And NOAA staff can create an account, and there are currently 255, as of yesterday, users within NOAA. And this page is publicly viewable, and the NOAA users can also create internal groups to share data internally. And I created this NOAA internal group with just a few people, and then this is where I have all the layers and the maps shared as of now. And there are 9 web maps and 35 layers, but there are a lot more to add to it. So, okay, so this is an example of what a web map on ArcGIS can look like. It is an interactive map, so you can zoom in and out to wherever you want to look at, and you can also change the base map because Esri provides like DEM and street map and ocean, different base maps that you can just choose for your different purposes. And you can also click on different things on the map to get these pop-ups, and you can get more detailed information on what you're looking at. And this is an example of how a web map application can look like. So web map application is like a published version of a web map. So you can access through URL links, and this can easily be embedded in websites. So it's really useful. And yes, but so like I said, it's still in it's work in progress because I still have to, or these web maps pop-ups have to be configured. At the end, each pop-up should have a link to a PDF file of the metadata and how the data can be downloaded. Okay, so this is a big project, and so there's a lot more to be done, but I hope what I did so far has been helpful. And so these are just some, I guess, next steps for me and for the project. So there's a lot more configuration of metadata and symbology and everything on web maps on ArcGIS Online, and I can also keep cataloging for more and looking for more useful data. And finally, then the maps can be publicized as a web map application. And we should also report back to the partners. And when we went to the Big Island, all of the partners talked about how like these maps should be a living tool or a document because they should be able to add more data or edit as they do more research. Okay, and Heia is another Sentinel site that's in Oahu, and Jess and Anna will talk more about that. But I had an opportunity to like go there and meet the people, and they do really beautiful and great work. So, and a lot of the data layers that I've been using for Big Island is statewide. So I'm hoping I have 1 more week after this. So I hope I can do something so something can be useful for that area. And so what did I take, what am I taking away from this summer? So working on the Sentinel site and Habitat Blueprint project, I got to learn how kind of like science management and outreach go together. and how different partners perceive NOAA as of like what we are capable of doing. And yeah, like just learned the importance of data sharing and partnerships for effective management. And yeah, and also that I haven't really used ArcGIS Online before in class, so it was really nice to learn more about it. As I think it's evolving tool that's going to be used a lot in the future as means of data sharing and collaboration between different groups of people. And there are certainly a lot of challenges and limitations still, but I think it has a lot of future potentials. And I became more interested in like free open source GIS this summer. Yeah, and so, yeah, and this summer I really enjoyed learning about and getting to help out with also like other projects and events with other interns and all of PSC this summer. And I guess the overall experience definitely gave me a lot of good new insights and food for thoughts of what I want to do, what I might want to do next summer for my master's project, and what I want to do after I graduate. Well, okay, I guess I'll say it now. So I'm finishing up my bachelor's and then doing a master's degree, 5th year thing next year. And I'm really interested in like disaster management things using GIS, especially for tsunamis and earthquakes. And just because if you, kind of like Alex said, like data is power, knowledge is power kind of thing. If you know, then you can act. So I'm interested in that field. So hopefully I can get a job in that field. So with that, I would like to thank all of these people for making this summer really enjoyable and possible and unforgettable. So thank you. If you have any questions.
Any questions? Yes, I have one. If you were here for longer than 1 week and you had complete freedom to pursue the habitat blueprint and on-site project yourself, what would you like to add to the project?
I think it'll be really cool if I could go back to the Big Island and meet all of the partners again and be like, oh, this is what I did. Like, no, yeah, and yeah, yeah.
So, Doug, if you could come say a word or two.
Thank you. As you can kind of tell, Machino's a very depressed and dark person. Honestly, it was a ton of fun having her in the office this summer. She was super adaptable. When she first was coming here, we actually were going to station her in Kona and have her work from there. And there was a couple limitations that worked out, not the least of which is Machino had never driven in America. So we thought that the Big Island probably wasn't the best place for her to learn, but I mean, she tackled the project like she was pointing out. It was a huge project. The horizon was sometimes tough to see for her because it's a project that when she leaves and when Alex leaves, the two of them worked hand in hand in this with Rob, who I need to thank, because he really served more as her mentor than I did. I just got the fun stuff, basically, taking them out for happy hour every once in a while. Rob had to do the heavy lifting of actually showing them and teaching them. But you know, it was tough because it's not a project that at the end of her time is going to be something where she can hand, you know, a finished product. But it was enough that she kept hammering away at it. Really loved it. She was a ton of work, or a ton of fun to work with. And that was not an intentional slip. She was a ton of fun to have here. She's very smart. Hopefully when she graduates, we can find an excuse to get her to move out here to the Pacific, because it'd be great to have her skill set and mind out here. So.
Thank you, Doug. Next up, we have Jessica Lilquist. She attends Smith College and is in the Environmental Science and Policy program. She is also here working for NOS, and her mentor is Doug Harper, as well as Rob. And the title of Jessica's project is NOAA's Sentinel Site Program Hawaii Cooperative, Climate Change from Observation to Stewardship.
Okay, thanks for sticking around, everyone. I know this is going pretty long, but everyone's presentations have been awesome. But like you said, I'm Jessica. I'm originally from Connecticut, and I go to Smith College. My major is Environmental Science and Policy, with a minor 5-college certificate in Culture, Health, and Science. I applied for this internship through Smith, through the Environmental Science and Policy program, which actually has a really great fellowship program in which it advertises NOAA internships every year that are funded through the Agnes Jed Andre Fellowship Program, who is a Smith alum who donated money to promote women in scientific and environmental research, which is really awesome. And I specifically applied for this internship in Hawaii with the Sentinel Site Cooperative because I wanted to learn more about NOAA's local initiatives regarding climate change and risk management. So, this summer I've also worked at the Pacific Services Center with Doug, who's been an awesome mentor. But instead of focusing on one project, I actually had 3 major tasks with some side projects in between, and most, if not all of my work related directly to the Sentinel Site program and also involved some work with the Habitat Blueprint program. But because Machino and Alex both pretty well explained the general goals and focuses of the Sentinel Site and Blueprint programs, I won't repeat what they said. But I would like to just talk a little bit about what the Sentinel Site program is, because that's who I work primarily with. So the Hawaii Sentinel Site Cooperative is one of 5 established Sentinel sites nationwide. Others include Chesapeake Bay, North Carolina, the northern Gulf of Mexico, and San Francisco Bay. All the sites were selected based on their unique coastal environments and due to their dense human populations. The Hawaii Cooperative, though, is really unique because of its focus areas spread across the Hawaiian Islands, including the Midway, French, and Frigate Shoals, the North and the Northwest Hawaiian Islands, the Hilo Wetland Restoration Project on the windward side of Oahu, and the Kona coast of Hawaii Island, and the last 2 being where I did most of my work. So, as you can see, my 3 major tasks were creating a crosswalk, and a production map for Kakauivi, which was GPS and GIS mapping, and also a grants compilation for 2014 and fiscal year 2015. So my first major task was a crosswalk, creating a document compiling all the habitat blueprint files that NOAA has. And I basically formatted it like a literary review or a detailed table of contents, putting together past, present research, management plans, and proposals for conservation and climate change related work in the region. And we called it a crosswalk because basically we were taking work being done in different areas of the region and compiling them to find ways that they overlapped and to figure out what their main goals were. And it's meant to be a living document, sort of like Machino was saying. Her maps are supposed to be living maps, continuously and consistently updated when there's new research or management plans that develop. So also, like Alex and Machino pointed out, the Sentinel Site and Habitat Blueprint overlap pretty well on the northwest area of Hawaii Island. So it's pretty cool that we all got to work together and go out there together to talk with the partners. And so after meeting with the partners there over the course of 3 days and showing them the template that I had created, we determined that my document would serve as a resource for the groups involved in the program to outline work that has been completed and that is underway. And actually, I have several updates and additions for the document still to make next week, thanks to the information provided by the partners on the Big Island. Just for fun, some pictures of our activities there. That's the group of 4 of us that got to go out there. And some of the sites that are actually part of the Blueprint and Sentinel sites. In the bottom right corner is Puako Fish Pond, and in the top is just the Lone Palm for Inky Line Fish Pool. So my next main project was making a production map that is part of the Heia Sentinel Site region, and that in part came up because Doug knew I wanted to gain more experience in GIS mapping, And that involved the NOAA Sentinel Site Program and Kaka'oiwi, which is one of the groups out there in Heia. And the map is supposed to be of various crop plots at the site, and we were creating it to help them make a framework for the organization so that they could more easily track crops that they are producing and to record and manage the rate at which certain crops are growing and when they're harvested. And it's also additionally being able to track this information can help them assess how they contribute to the community in terms of dealing with food security, as well as how their resources are or could be affected by sea level rise, coastal flooding, or even water contamination. Just to briefly show where Heia is with the windward side, most of you probably know, but this is actually the map that Anna, who had my internship last year, created. And it just shows the general area of all the Sentinel site groups that are out there. And right now it's pretty cool because Heia is so easily accessible to NOAA because of NOAA being based on Oahu, and it's a short drive away that the Sentinel site has really been able to focus on that area. And a little bit about Kaka'oiwi, where I was doing most of my work and taking the GPS coordinates with the great help of Machino. This group is a 501c3 or tax-exempt nonprofit organization whose mission is to perpetuate the cultural and spiritual practices of Native Hawaiians through science research and agricultural practices. In the beginning of the summer, I met with some of the Heia Sentinel site groups to learn about their ongoing projects and to figure out what GIS work that they needed. And Kaka'oiwi expressed interest in building a framework for tracking the crops that they were producing in an efficient and visual manner, which is where my map comes in. Their main focus is kalaloi or taro fields, but they're also working on growing more of a variety of crops, which is what's going to make their inventory more complex. Just some pictures of us getting to do GPS work and some of the plots that they've already cleared out there. This is what I have so far for the map. It's a lot simpler version compared to the projects that Alex and Machino are doing because it's very local and specific. But based on the measurements that we took and the information we gathered, I was able to define the plots on their land, and actually already there are other plots that have been created that we weren't able to get the GPS coordinates for. But that's what's so great about ArcGIS Online is because when the map becomes publicly available, Kaka'oiwi staff members will be able to update it and edit it in any way that they need to or want to. And, excuse me. Also the pop-up functions to label the plot content, crop quantity, as well as dates of planting and harvesting in order to track the rate of production were included. Right now it's still kind of a draft because we're working on getting more accurate and up-to-date base map just to show that they've cleared a lot more land, and thanks to the help of Ross, who works in PSC, hopefully he can get some really accurate LiDAR data that was taken a couple of weeks ago. And I also need to talk with the partners about what they specifically want to label in each plot. The hope for this map is that Kaka'oiwi can use the map and keep it updated, editing it continuously to track production rates. And also, if it works out and other Sentinel site groups find it helpful, it could be used as a model for NOAA to apply to the needs and activities of other Sentinel site groups. Oops. So my final and third project was what NOAA specifically needed for the Sentinel site program. And I made an Excel spreadsheet of federal grants that are available for 2014 and fiscal year 2015. The funds are being offered by NOAA and other federal agencies such as USDA, EPA, USGS, USAID, the National Science Foundation, FEMA, Department of Health, and most of them are meant to support research needs related to climate change or for community resilience and management plans. And it's also for potential projects for regional nonprofits and private sector groups. It actually started as a side project, but when I was looking at all the information, more and more grants kept popping up. So I've actually now compiled about 50 grants, and there's a lot more to still go through. But yeah, that's where I'm at right now. Another fun side projects that I got to do just shows that I've been able to do a lot this summer and with NOAA. So it's been a really great time and I've learned a lot. Acknowledgements, of course, the Pacific Services Center. It's been so much fun working with you guys and it's been a really fun environment. And basically, I guess to conclude is, these projects that I've been working on are meant to support the partnerships between NOAA and local communities in their efforts to improve climate change resilience. I've learned a lot this summer about the programs, about NOAA, and about Hawaii, and I also believe that the Hawaii Cooperative serves as a model for strong, evolving collaborations between scientists and community managers. So,
Any questions? Yes, I'll ask a question.
Okay.
So you showed value in small-scale projects being
Yeah.
valuable in communities. Do you see an example that you could take back to the mainland for a school, perhaps?
Oh, I think definitely. I know of, sort of like Kaka'iwi, there are a lot of local farm projects that happen in Northampton, where I go to school. So I think it definitely can be applied, like taking these global issues and applying them to local communities just to see how people can deal with them themselves and like what they specifically need to create issues that also might arise in the future.
Part of the reason was Anna did a great job last year and set a very high bar, and both Jessica and Machino nailed it this year. Jessica was fantastic, whereas Machino had the project that, you know, Sisyphean, the end of it was where she was never really going to see. Jessica had 1,000 projects that popped up, and I would just kind of throw on her plate and say, we need you to do this, please do this. And she would tackle them, do a great job. She was super easy to work with. Like Machino, she was fun to work with. It's going to be really sad seeing both of them leave next week because they've been a lot of fun having it in the office. They handle their tasks gracefully. They do them extremely competently, and much like Machino, and I'm duplicating because they have so many of the similar strengths. But hopefully we can find some way to bring Jessica back out here. So if anyone has openings, consider her. Thanks.
Last but not least, we have Anna Campbell. And as Dawn explained to me, she was with us last year and was also the final presenter.
Really?
That's what So Anna also attends Smith College. She is studying biodiversity, ecology, and conservation. And she is here with us at NOAA, at NOS, a Hollings Scholar, working with Doug Harper. And the title of her project is Digital Storytelling for the Environment.
Hey. Hi everybody, thank you so much for sticking it out to the end. Means a lot. So yeah, I want to keep this short and sweet because my project is pretty self-explanatory and is actually a little over 10 minutes within itself. But yeah, I'm part of Doug's cohort. I was out here last year working with the Sentinel Site program. And I'm back sort of working with the program with the themes of community resilience, but it's a bit of a different project for my Hollings project. And we called it Digital Storytelling for the Environment. So I made, over this summer, actually sort of starting the planning process over the course of the school year, and then going into this summer, I made about a 10, 15 minute, well, 13 and a half minutes as it currently stands, a short outreach video about one of the Sentinel sites, Hilo, which Machino and Jess already touched on. So yeah, there's a lot of great restoration work going on over there, and the partners had expressed that something that they could show potential funders and visitors and even people statewide or even outside of Hawaii as sort of this place is serving as this model for community resilience. So I'll just let you guys watch it. This is not the most up-to-date version, but I guess it's never really done, so let's see if it works. Sweet. Maybe we have sound too. Yeah, I could
could sing the music, that would work too. Pretty much know it by heart. Ooh.
Land division that stretches from the top of the mountains, incorporates and includes our cooler lands, our flat lands, extends to the beach and then out and inclusive of the reef. And Ahupua'a was intended to provide access to all the resources necessary for sustenance and life. But I think more importantly, what an Ahupua'a is and what we need to try and reestablish are those connections, which allows for all of those other things to fall into place. So reestablishing, the connection between Moka and Wakai, knowing who's upstream of you so that you have that level of accountability necessary to be able to grow your crops and feed your community.
Right now we're actually in the Haiku Valley, which is in the back of Heia. This is where the water gets caught. There's a spring that kind of bubbles up from this area and feeds the stream. Papahanaukuola's mission is it's an awesome mission, but it's very big. So at times it can be challenging. But the mission itself is about restoration and sustainability through traditional Hawaiian knowledge that honors the connection between Kanaka, Aina, and Akua. Kanaka being man, Aina being land, and Akua being that higher power, the spirit. We don't talk about resource management or stewardship. We actually look at it as source kinship, that we are families with the land. We try to develop our familiar relationship with the source. We look at data in all kinds of ways, and we look at all kinds of different things as data. We don't only look at numbers, we look at songs, we look at chants, we look at histories, we look at mo'olelo to tell us and share something about the space and how we should react and how we should act in the space. We take up thousands of invasive species, we restore the taro patches, we restore the stream, we replant thousands of native plants, and it looks pretty beautiful. And that is a success and something to be very proud of. I think the biggest success is starting to see the development now of people engaging in that space in a way that is honorific and restorative, not only to the land but to themselves. We talk a lot about in our division about restoring land with the people that need the most restoration, work themselves. Heal the land by healing yourself. This stream system is probably one of the more cleaner stream systems around in the state. And we have areas and springs that we actually can drink from. So the scary thing is, what if that changed during my lifetime? That I let that go? That's a burden. That's a sense of responsibility. It's a kuleana to try and maintain and improve the ability to access clean water. And if something happens, we have clean water to drink. And at Papahanaukuola, there is a waiahu, or a water pool, a ha'akolea, that we identify as kind of like the headwaters of our program. Within mo'olelo or myth, that pool is actually identified as a place where one of our goddesses, Kameha'ikana, would go to wash her limu and crab. Even the spring waters, the story goes that Kane and Kanaloa provided those springs. And they left those springs for us after they drank their ava. They would leave the springs so that the people could utilize the fresh water to cultivate new food, to use to drink, to sustain their community. If things are good enough for our gods, we have the responsibility to maintain it at that level. That's good, and we know it's good enough for us.
The stream is important to us at Kakoiwi for the very fact that it's a physical reminder that we're tied together. It's a physical reminder of what occurs Malta or in the uplands. Directly impacts us at Kakuivi. What we do in the stream now directly impacts what our friends and our family does at Pai Pai, and it directly impacts what occurs in the reef system. So the stream is just a reminder to us of our obligations to each other, and that's what really why we gotta take care of it. The families have been here for thousands of years. Kakuivi, we started working here in 2007, and hopefully we'll be here for a lot longer.
I think Kakuivi's vision is to restore the parcel that we're on. It's 405 acres. With as much kava as we can grow on this piece of land, I mean, we could seriously feed so many more people. And not just food. There's 1,000 different ways to feed people. Sometimes people need knowledge. Sometimes people need places to run away and refocus. Sometimes people just need food. But I think because of the kind of place we are, we can afford to do all of those for everybody. 400 acres and single-digit crews. That's probably the biggest challenge. We have a real small crew and a really big place.
A bigger challenge is going to be how the climate and environment changes, and I hope that I believe we'll have the labor and the capital to adjust to those situations.
I think it's important. It's important for us to know each other. It's important for us to help each other. It's important to see the faces of the people that you really, in the end, ultimately answer to. I think that's one of the big challenges of today is everything is so disassociated. Yeah, I don't know that guy, he lives down the road. How many people nowadays know neighbors on the entire block? And not just know them, but talk to them, converse with them, help them, worry about them, care about them. Here, it's not a block. I'm on 400 acres. I have 1,000 blocks here. But when you think about water, we're super close. If you spill 1,000 gallons of hydraulic fluid, I can count minutes until it starts to bleed down to the next person on the river.
We're not really sure where the stream went originally. That stream is going to divert or change path again, and we need to make sure that our families and our community is resilient enough for that change to occur and resilient enough to respond in the correct manner to continue our projects here at Hilo. That's what we're hoping.
When you have a lot of people, how do you incorporate people together to move in a direction that is functional and productive?
Lau Lima means cooperation, working together.
Lau is 400, it's actually a number.
Lau meaning leaf, or meaning plenty, numerous.
Lima is your hands. So
We all have to put our hands in to work, you know.
There's many leaves on a particular tree. So if you imagine all of those lau were hands, oh, the work that could be done by us many hands.
Because of our isolation, we're unique.
When you're living on an island, you develop an island mentality.
You become very resourceful.
You have to always think finite.
A lot of times we try to push that away and try to behave as if we're continental people, but we're not. We're island people.
So we have to kind of understand, like, we're all on the same water system.
You want me to talk about the fish, but I'm going to talk about the water. You want me to talk about the aqua, I'm going to talk about the water.
if somebody is downstream from you and you screw things up, you should know what their face looks like.
Do we have water now? But if something happens, do we have enough water to sustain ourselves over a period of time? You know, and that, I don't know. I don't think so. I'm very scared about that.
I'm a speck of dust. You know, as good as I can possibly be in the entire span of my life. Really, in the entire span of this land, I'm a speck of dust that made a minuscule difference. But if I can extend my influence, if I can extend whatever I'm responsible for one more generation, and if that generation can extend one more, if I can affect people through education, it's exponential. There's one of me. If I teach 30 kids, already that's 30 that learn. If only half of them go out and do something, that's 15. That's 15 times what I can do by myself.
Main thing is they receive whatever they get here and make it better for the future.
Climate change and food security and El Nino and global warming, the island communities and the island nations are feeling the effects now.
It's just really that basic respect that you have for an ecosystem and considering yourself to be part of the system.
And that's the same thing that we think about globally. That whatever we put into the ocean, whatever we put into the sky, whatever we put into ourselves has to not have a bad effect upon someone else.
PA presents that opportunity for us to be successful and achieve those reestablished connections and relationships.
And that's thinking island.
Huge thank yous to everyone who made this summer possible, and this project. It was honestly, I'm not usually a gusher, but like this was the summer of a lifetime. Like this was amazing. This is exactly what I would have. Yeah, it was wonderful. I'm really into science communication and the idea of incorporating science with resilience to actually make a positive difference in our future. So.
Thank all the interns. I was, over the course of the day, very impressed by the projects and the presentations, and the mentors for mentoring. And it's been said numerous times today, but thank you, Don. I think without his tireless efforts, we wouldn't have had such a good symposium. So,
Everyone's already heard from me. So, yeah, I mean, Anna was an intern last year, did such a good job that we kind of fought when she mentioned that this was something she'd be interested in, to be able to get her to be able to do that again. If you had any doubt about what the office thinks of her, you should have seen people's faces when I told them that she was coming back this summer, because everyone was exceedingly excited to have her back in the office. And as you saw, she's incredibly talented. And I'm going to cut it off there because we actually do have to go to Haiti and show this video to them in 30 minutes. So, thank you.
Well, thanks for sticking around till the end. I just want to thank all the presenters. Let's give all the presenters today a round of applause.